I'm saying, personally, I believe the things that you teach your child, your autistic child, is
How do
psychological
you-
child abuse.
Like that water is level.
No, you teach your child that level is a horizontal plane, which is not true.
Yes, of
And
course
the
it is.
implication of that is that you are teaching your child the earth is flat.
No.
Yes.
Well, it's a question for Jesse. I just want to know, is the level a drop from the horizontal? A measurable drop from horizontal?
Let them dance.
There you go.
Yeah. Jesse, did you hear that question from Bev? Make sure you're unmuted, Jesse. When you join, is muted. Ask again. Try thinking here. Jesse should be listening.
Go ahead. Sorry, I was on mute and I just came back in.
Right, Jesse, you said the level is not horizontal. So is the level a measurable drop from the horizontal?
I did not say that the level is not horizontal. I said horizontal and level are coincident with each other at one point only, and that's at the plumb line where the observer is.
Oh, yeah, I heard
The
that.
level surface drops down from the horizontal plane at a rate of 8 inches times the distance in miles squared. How many times?
Measurable, right?
My question is, how many times? Oh, yeah, it's measurable. It was derived.
That's all I wanted to confirm.
You can measure this. Have you tried measuring this?
Yeah, so you are saying that a water level drops away from the actual level. You know, when you set up an auto level.
No, I didn't say
they're
that.
different, aren't they?
No, not really. An auto level.
George, I was asking Jesse, what are you doing?
An auto level.
You're speaking for Jesse, George.
I can't join in. You can't either, man.
George, let me talk to this man.
Go ahead. Go ahead, Jesse.
Thanks. Okay. So how many more times must I explain this to you? I've explained this to you on Twitter, on YouTube, and now we're here in person finally talking to each other.
Yeah.
How many more times?
You're saying that level drops from the horizontal. A level is a tool that establishes a horizontal.
My question to you is, this is my question. How many more times do you want me to repeat this same
heard one straight answer. Give him a straight answer.
All right, Brian, I'm going to have to lose you from the call. Only Try Thinking and Jesse Kozlowski are the only two persons should be heard right now.
So that's my question to you, is how many more times do you want me to repeat the identical answer I've been giving you? I don't know. Is this months now since you started following me on Twitter? And
okay, well, can I go over it then and tell you what I understand, and you can just confirm or deny it, right? Just to make sure. You're saying that you can set up a level.
No, I just asked you a question. I'm asking you this. How many more times are you going to ask
just
me?
Just this one, Jesse. If you make it sure and let everybody know that you have definitely answered the question that I've asked, then that'll be the last time, Jesse. Promise.
So this is it. Drum roll. This is it, right, Brian? What's your name?
Do you know the question? Do you want me to repeat the question again?
Yes, you're going to, but I wanted you to answer me that one question. How many more times? You're saying this is it.
Right, yeah. If you answer the question this time properly and not obfuscate it.
Have you seen my answers before?
You've never really answered the question. That's why I keep having to ask to clarify, Jesse.
All right, let's try it.
Okay. Do you want me to give you the question then from full?
Yeah, let's pretend it's the first time.
Okay. I'm at the side of a canal and I have set up an auto level. Right, that is establishing a horizontal line of view, right, through the crosshairs.
Correct.
Right, and now I am at the side of a canal. Now that canal is water level. It is horizontal too, I say, but you say it drops away. Now, can you measure that drop of the water level away from the horizontal level of your auto level?
Perfect. Let's try to, Jesse, address you without interruptions. Go ahead, Jesse.
Yes.
That's pretty clear.
Can you do it without using perspective?
Why not? Why not refer
Whoa!
to ring
I
light?
don't think that was that it. Was that it? I heard Brian. I heard George, but it was supposed to be Jesse and Bev, like sorting this out and sealing it up for the last
Well,
time.
but
So
he said
let's give him an
is.
extra minute.
So you say it can be measured. What sort of distance can it be measured at, please?
What distance would you like to try to measure it at?
I don't know. I'm asking you, what distance can you measure it at? All of these people around here are thinking you can do it. So tell these people at what distance you can measure the drop of the water level from the auto level, please.
Well, first of all, I would take someone who is actually a surveyor over whatever you say any day. So.
This is just a picture of him showing what it looked like when he leveled his other device.
Yeah, because you can't put a camera on it, can you? It invalidates everything.
He has not linked a picture yet of when he pointed it at the target.
Do we understand? At the target there.
He's leveled and it's above the target.
Yes.
That's the point. That's not the measurement picture.
What's the measurement picture then? Right, because he's sighting at a target. The target's about 10 inches square. Isn't it?
Yeah,
or do you not know? You don't know what the target looks like, do you?
What's the reference? The other theodolite.
It's not a fucking other theodolite, B-ball. It's a target. He's got the theodolite. It's a target.
Yeah, well, okay, how high is the target, Bev?
I don't know. It's there in the picture. It's below the crosshairs.
I think they're both the exact same height. Do you think?
Right. Well, why over half a mile is he over 10 inches out? Answer us that. Go on.
Because the Earth is curved.
Oh, 10 inches over half a mile.
Mm-hmm.
Yeah. Yeah. Well, that's a trustworthy fucking surveyor, isn't it?
Mm-hmm.
What's the numbers? What's your dogmatic globe numbers, B-ball? Half a mile.
He's an actual surveyor.
Half a mile, B-ball. What's the dogmatic globe numbers? Half a mile.
Well, you're not a flat earther, so I wouldn't ask you. So
you wouldn't know.
Earther,
I'll tell you. It's a quarter. It's a quarter of the mile because it's a quadratic function. So you're looking for 2 inches. But he looks like he's over 10. I'd say he's more like a 12, 15.
How high is the target?
It's meant to be. It's meant to be at the same height, isn't it?
Yeah. For some reason, it's above. I don't know why. What's going on here?
Oh, I'd say Jesse Kozlowski's fucking fooled you completely. He's fooled a lot of people.
Of course.
Yep.
Of course.
Absolutely. Yes.
Of course.
If that's the case, and we've got all these hundreds of videos of Globers doing these measurements, documenting them, detailing them.
You've only got Jesse Kozlowski and Larry. That's all you've got. Oh, and Jeff as well.
So
they've all gone.
Wait a minute.
They've all gone.
What I'm getting at here, and I always bring this up, is there's not a single flat earther that has gone out there and shown us that we're wrong. Not one. Or at least
we don't care about the flat earthers.
At least
I'm just bothered about this picture.
Okay. What you haven't
Can
done
we have a
is
consensus view? How high above the target is that crosshair? Everyone, come on in the chat now. How many? How far would you say? The crosshair's above the target.
Have you measured it, Bev?
No, I'm just going to say, like, eyeballing it.
Well,
how high is that crosshair above the target site?
It should be pointing directly at it, Bev.
It should be 2 inches above the center of the target. Now, please tell me how far
Why is it not pointing directly at it?
Is it?
People, you are talking right over it, man. Come on, let's try to go one at a time. To me, I'm zooming in on it. It looks closer to what Bev's saying. If I had to estimate, 8 inches, 8 to 9 inches, maybe 10.
Wait, but Geo, look at what Zanuck posted, the measurements. How did he get those?
We've explained it already.
Because he measured it many times.
How?
Not just once.
He copied it from somebody.
Maybe you should watch the video. I'm sure you
Look
guys
at
have
that.
seen the video.
It's
many
gone to
times.
the decimal place of an arc second.
Yeah, but
Yeah, I don't think
that's the thing. Like what Bev's saying, like, how did he get to those? Like, what was his reference point of measuring to?
Buster, he pointed it at that. See that yellow thing in the picture?
Mm-hmm.
Yeah, it's above.
It's above it.
Yes, but listen, this picture is not him doing a measurement. Do you understand that?
No, putting a camera
When he
on an
Bev,
auto level
Gio,
or theodolite invalidates the thing.
I don't
Yes.
think
But
Xanax- I
here,
don't think
here's
we
the
finished what
like.
you're saying.
That's true, but like, here's the thing. How do you get an arc second over a half a mile?
Why is that a question?
Because he has decimal points after his readings.
So what? What's the problem?
That's past.
That's from
an arc
isn't
minute.
that from
It's
level?
arc seconds. It's a decimal point. It's like past arc seconds.
Isn't that measuring from level?
Do you guys know where this test has actually been done? This sighting test to see how far and what you can see over a certain distance. Do you know where that test was actually done?
Bev,
do you know where that test was actually done?
Right now,
Buster just asked a question, Bev, and you stepped
it
all
was
over
done.
him to ask.
It was done
I guess
here.
I'm gonna keep talking until
it was
Bev
done
decides to stop talking.
here on this Discord server. You keep talking over it.
What do you think, Gio? Is this how you want to
Well, let's just go one at a time, please.
I appreciate that.
Well, that way we can hear what's being said. Because obviously, if two or more people are talking, we really can't hear anyone. So if you want to be heard, then obviously we have to all speak one at a time. Because otherwise, no one can be heard. We're here because we're obviously wanting people to hear what we're saying. So might as well let each other say it. All right. So what were you saying, Bev?
Saying, remember when we went out on Blackpool at Southport Beach?
Sure, we all do.
To show you guys exactly what you could see over 500 meters, because a certain person had claimed that they could sight to an arc second, even though it seems like they're writing down decimal places of arc seconds. Well, it turns out that 1 arc second over 500 meters is 3 millimeters. And we showed you what you can see over that distance here on this
you also
server.
wound up proving curvature with that picture too.
No, we didn't. We proved that the guy that's writing down those numbers cannot measure to those angles. He can't get it. Can't see it, B-ball.
Well, it still begs the question, like, how did he get those measurements that Xanac posted?
He pointed his theodolite at the yellow thing right in the middle at the post.
Where at?
Yes, that's what he did. He angled his theodolite down until the crosshairs were in the center of that thing, and that took measurements from there.
Okay, and how accurate is that over half a mile? What's the distance of a half a mile?
What's the distance of a half a mile?
Distance of a half a mile.
It's like a quarter mile. It's like a quarter
Dogmatic,
mile.
get the Ruhif numbers out.
It's only about a quarter. Hold on.
I'll
It's
get
only
the
about a
Ruhif
quarter
numbers.
mile.
I'll get them for you.
It's only about a quarter mile.
It's
like 1,200 feet, I think it was.
It's a quarter mile. Holy shit.
Yes.
And he's that far above the fucking target. Zanuck, I don't think you should be talking, mate.
Is this?
Why is
is
that?
this? Well, Negator, did you say that this picture? Hold on, Negator. Did you say this picture wasn't the actual measurement?
Wait.
No, as far as I know, that's the picture of just him showing what his horizontal looked like.
Explain how you get explain how you get accuracy with an angle on a theodolite, Negator.
You mean? Wait a minute. Theodolites measure angles. Okay. Your question is, how do you get an accuracy of an angle with a device meant to measure angles?
Yeah, how do they do that?
I don't understand the question, Buster. Can you rephrase it in another way?
You just rephrased my own question, and you're saying I need to rephrase it again. How do they get that measurement within that instrument?
You mean like the actual mechanics of it?
How do they get the measurement that he has posted, that Xanac posted? How do you get those measurements with a theodolite?
Well, the theodolite optic is, let's say, 6 feet off the ground, right? So you set a post somewhere else 6 feet off the ground. Right, particular point. And then you measure from your zenith. From me to it. Does that make sense?
Zenith.
Or vice versa
Vertical?
from your
Wow.
down to it.
So you point the scope up and then measure. I don't know. You're
No, it's
explaining
zenith
this,
angles,
not
does it
me.
not?
I don't want to explain it for you.
Okay.
Reciprocal zenith angles, isn't that what it measures?
So you don't. Why would you point the scope? So the scope itself has something called a laser plummet inside. It's the same. It's effectively the same thing as a plumb bob, just way more accurate. So you simply set it up, do some basic leveling. All right, it's got a little bubble level in there, and it already knows which way up is based on that laser level or the laser plummet that's inside. And then you simply point it at things vertically, and it tells you an angle off of your vertical.
I think Bev has a problem with the picture because
Zanuck, you're
Yeah.
not you're helping him, but you're not helping.
well, I'm
Like,
trying to help
There's two different
anybody who wants to help
measurements.
here. The picture
Whoa, whoa, whoa,
shows
whoa.
it
No,
not
stop,
above
Zanuck.
the.
I'm talking with Negator here, and you're interjecting to like divert the conversation.
I'm not trying to divert anything.
Yeah, I think you are.
I'm really not.
He has number 1, number 2, number 3, number 4. He has two different measurements.
Right.
How does he get those?
He has 4 measurements.
By
Those are
reading
the
the
reciprocals.
display.
The one that you posted,
Nope.
there's
By reading
5.
the display.
Yeah, the device tells you. You
He
point
read
it
the
at something and
display.
it tells you.
He did 4 different days. So yeah, I'm sorry. They're 4 different days, but multiple measurements. I had the data also earlier, and the series 1 gives him a reciprocal zenith angle of 17 degrees. The second day had a reciprocal zenith angles of 20 degrees. Excuse me, 20 seconds. The third had 13 seconds. The fourth had 12 seconds. So the mean was 16.2 seconds, divergent of the plumb lines. That gives you this with a standard deviation plus or minus 2.8 seconds. Okay, so there's your standard deviation of the mean, 1.4 seconds.
You totally word saladed and talk shit through that.
No, I didn't at all. 4 series, 4 days, right? The reciprocal zenith angles of that first day of measurements, a bunch of measurements, gave him 17 seconds, arc seconds. Second day, 20 arc seconds. Third day, 13. Fourth day, 12 arc seconds.
That's not what I'm talking about. I'm
But
talking
that's
about
what he measured
1, 2,
over.
3, 4, and 5. And I was asking Negator how you get within the accuracy of those arc seconds. And he doesn't know, and you obviously don't know either.
Well,
so
do you
somebody
know?
does
You know how
know-
you would want to find out? You could go and type in how to use a digital theodolite, and that might tell you. If no one in here can give you the answers you want,
Yes,
you
he
can go
wasn't
and do
using a
research
digital
yourself.
theodolite. It was a T2.
Okay, great.
Okay, so don't
He's
bother
still got the
talking about
measurements,
shit
right?
that we're not
He's
talking
still got
about.
he's still got the measurements though, right?
Well, he wrote them
Or did he
down
make-
in
or did
pencil
he
on his
make some
book.
shit up?
Yeah, he
Definitely.
wrote
right, he
them
just
down,
made
but
them
nobody
up.
seems to know how he got
Right,
those
he
to
just
write them
made
down.
them up.
B-ball.
Well,
B-ball.
well,
he just made them up.
B-ball, you explain how he got those numbers that he wrote down that Zanuck posted.
I mean,
How would you like me
Buster,
to explain that?
I've already told you, Buster. It's like asking how to use a compass. Well, you look at it and it points at a degree. With this device, you look at it and it tells you a degree. What's the problem?
Mm-hmm.
You're doing a terrible job, but like.
No, here we go.
Those are the degrees he got from this theodolite. He measured the degrees.
How do
He
you
wrote them down
on the
how do you
screen?
get-
It shows. If
I'm
you
trying
look
to
at
answer you, and you keep on asking the question. You're not listening. Those
if you look
5
at the
measurements. I had the
screen,
4
not
days in series.
shows
Those are the details of the measurements of that day, the temperature data and the angle data, and the angle data all adds up, and then he has the values at the end.
I'm asking how he got those arc second measurements, and nobody
because
in here
on the
knows how to
screen,
explain how he got
listen.
them.
On the screen of the theodolite, it has a digital screen. He most
No,
likely
the
looked at
T2
the
doesn't
screen
have a
and he
digital.
read the measurements.
It's not digital.
Nobody knows how he wrote those measurements down. This is amazing.
I don't think you know what you're actually saying right now.
I do. He has the number one. This is what I'm looking at what Zanuck posted. Zanuck posted those.
This is what happens when you take your argument from someone else.
What argument, B-Ball?
Okay, let's back
We've
up.
already been through all of this, guys.
I think you're getting confused, B-Ball.
Okay, let's agree.
Wait a minute, please. Let's get the argument from B-Ball that's being misrepresented. What's the argument that's being made here, B-Ball?
It's your argument that this gentleman who did these measurements isn't doing them properly.
No, I've shown that you cannot cite to
Right,
make
but he's an
these
actual surveyor and you're not.
measurements.
Okay,
And he's an actual surveyor and you're
Who
not.
is?
So.
How did you?
Hold on, B-Ball. You're kind of clipping him, man. Let's try to.
All right, sorry, go ahead. Sorry.
Just let, yeah.
The problem is that everybody that's trying to make a statement about what Zanuck posted of Jesse Kozlowski's numbers, but nobody knows how he got those numbers.
Okay,
I've been trying to explain it the entire time, but nobody seems to want to listen.
Can we agree to something, Buster, that these devices do measure angles, or is that in dispute? These devices are not capable of measuring angles at all.
No, they measure angles. I'm asking you how
Okay.
you got
Buster,
1, 2, 3,
Buster.
4, and 5.
Okay,
On the
you
top
don't.
left corner. How did he do that?
Okay, you agree that they measure an angle, right? Do you agree that they measure an angle in terms of degrees? Are we on the same page there?
Yes.
Okay, and if we break it, what's the next unit down from a degree?
Well, degrees, minutes, seconds. Everybody knows this, Negator.
We're not,
Hang on.
We're not talking about that.
Okay,
I'm asking
so,
you how
Buster,
Jesse
you don't
got
have
1,
to
2, 3.
say it again, okay? I'm a grown man. Please don't do that. All right? You agree that then it can measure in arc minute, correct?
Yes.
It can. An arc minute is a subdivision. Listen,
come on, Neg. Don't treat him like he's a child. He's a grown man.
An arc second is a subdivision of a arc minute. What is the problem with the ability to measure an arc minute, or rather an arc second, but not an arc minute? What's the difference?
You're still not answering the question. What those measurements he got, how did he get those?
Because it's from levels. From
write
level.
down.
Can I answer?
Wait a minute.
I've been trying to answer for like a half an hour. Let me just say like 10 words.
All right. Negator's out. Zanuck, you posted that picture. How did he get on the top left corner 1, 2, 3, 4, and 5? How did he write those down? What did he do? What procedure to write those numbers down?
He sights the crosshairs on the opposing target, and he gets a angle measurement that's digitally read on the theodolite. And if you're wrong, he has the theodolite that has digital readout, so you can get the accuracy that we're looking for. It's digital, and he writes that down, and then he can get the reciprocal zenith angles because the angles from both. Pardon me?
Are you talking about Jesse, or are you talking about the guy that probably doesn't live in Maine?
Maine surveyor.
All right, so we're not talking about the picture that you showed of the guy on the lake now, are we not? Are we swapping to somebody else?
That's Maine. Yes, no, the one on the lake is Maine surveyor.
No, it's not.
That's not.
It's not, Zanuck. No, it's not.
It doesn't matter whether it's Jesse or Maine surveyor.
It does, because you obviously don't know what you're talking about.
Yeah,
wait a minute.
I do, because I'm going to tell you how they did it.
But wait a minute. Wait a minute, Zanuck. You think, like, let's take number 1. There's 2 readings for number 1. You think that's citing to one side and somebody citing from the other?
Correct.
Wow. You are totally wrong.
Why do you say that?
I'm not even gonna entertain that. Like
No, because you have to have the angle that you measure to them, and then they measure from them to you, and then you should have an angle that adds up to 180.
The ignorance of this conversation and you posting that is beyond. It's just like, I don't know.
So here's what you guys can do, right?
How do you get reciprocal zenith angle?
People's posting it
You guys
there.
can
Look,
go
it's
out.
Jesse
You guys,
Kozlowski.
listen, great,
Can I finish?
great. You guys can go out, get the same equipment that this gentleman has, right? And you can go out and make the measurements and show that what he did is incorrect. Why don't you guys do that? Why don't you guys do that?
B-ball. I had a conversation with George about George. I don't know how you say
Listen,
his
if
name.
you're gonna
God
go
rest
off
his
on
soul.
something
I
else,
had a
I don't
conversation.
want.
Wait a
Okay,
minute.
go ahead.
I had a conversation with him, and he actually helped me understand what goes on with the theodolite. Like, I'm giving him props. Like, he helped me get a better understanding of what happens with the theodolite. Zanuck, on the other hand, with those measurements, showed his ignorance. I showed my ignorance in front of George, and he helped me figure out where I was looking at it wrong. So those measurements and what you guys are looking at, like, I did not realize that you guys had such a misunderstanding of what those measurements are. And I don't know if anybody does.
I want to say something to
So
Toffel,
what would you? Okay, so how would you how would you go out and actually? How would you come about doing this then? If it's all incorrect, if the measurements are wrong, why don't you guys just go
measurements
out,
aren't
get
the measurements are what the measurements are. I ask a question on how they got the measurements
how
in the
he
first
got
place,
them?
and
So
nobody
what you
here
can
can.
do, right? So what you can do, right, is you get the equipment, you maybe study on how to make those measurements, and you recreate. Listen, you go out and you recreate this actual test,
Bev
and then you bring those
already
measurements here and you
did
see if
in
they
this
match.
server.
No, you
Bev
didn't,
did
because
it in this
nobody's seen it.
server.
No, he didn't, because he never showed his measurements.
You couldn't see the measurements.
Exactly,
That's what
because you
we
didn't want
went
to
to
show.
show everyone,
That was the whole
people.
Right, because
Fucking
you couldn't
hell.
because you didn't want to show anybody. That's why.
No,
And
because
there were
nobody
never
could
any.
read the fucking measurements.
First of all, Bev, you were using an auto level. That's not that's
Yes,
not a
it's
theodolite.
got a better scope than he has
But it's
on
not
his
but it's not a
theodolite. All
theodolite
right,
though. But it doesn't measure. It doesn't
it's
measure
got.
zenith angles, does it? Does it measure zenith angles?
You can't measure to get accurate
Does
enough
it auto
over
level?
that distance,
Doesn't
people. Stop talking over
Bev
me.
Bev
Fucking hell!
doesn't
All
auto
right, go on
level?
then. You know.
Bev doesn't auto level measure zenith angles?
I don't know.
Can I make a point?
No, go ahead, Bev. Doesn't auto level measure
Does
zenith
it
angles?
fuck, people? It's a device
Does it?
for establishing a horizontal plane of reference.
Right.
Now,
Does it measure
can I
zenith
just a
angles,
minute,
Bev?
people? Can I ask Gio a
Just
question?
answer
Right?
the question, Bev.
You know,
Just
when
answer the
we
question.
came on here to do this, Gio, like we actually went out there on the beach with an auto level, strapped a camera to it on the level, and walked away 500 meters to show you guys what you could see. Can you remember that day?
Yep,
Right?
I remember.
Can you remember being able to sight anywhere near 3 millimeters? Like, because you would have to have moved the crosshairs 3 millimeters
Bev,
in order to
does an
measure
auto
1
level-
arc second. Could you have done that over that distance?
Can I
Bev,
make a point?
it was Jesse. As I started saying, I made a mistake and said it was main surveyor, so I corrected that. And I have the video here. We can watch it together if you'd like to see how he did it. That might be helpful.
I've been telling you guys for ages, right? You've been fooled by a group of people playing a game and acting to be able to do things that they can't really do. They're not real surveyors. And the reason you can prove that is they're not here. They've gone. They cannot defend their position that they've given you guys to discuss.
But then people
Okay,
like Zanuck
so why don't
think
we watch
that
the video together?
Think that
How
the
about
two
that?
numbers are the
and I'm the one that keeps getting muted,
back and
right?
forth.
Yeah.
Yeah,
like the
people.
reciprocal. Like, that's so wrong.
But it's okay for Bev to continue talking, though, right?
No, well, dude, you're completely over talking him. That's the only reason I was temporarily.
Yeah, he's doing the same thing, Gio.
Hold on. Just wait for your time and then speak. So, for example, now you have the floor. Go ahead. Instead of just talking over other people, because then we can't hear you or him. So go ahead now. You have the floor.
Oh no, I asked him a question. Do auto levels measure zenith angles?
You want me to reply again, Bebo? Seriously? No,
You never
an
answered.
auto level is a tool for establishing a horizontal plane of reference. Therefore, it does not measure vertical angles at all, because it only makes a horizontal plane, not a vertical plane.
But and then when you guys went out there, go ahead, I'm sorry. Go ahead, Zanuck.
I got to help out here. So he measures the angle of an angle to some pole, and he measures the pole height, and he centers it on that top of that pole, and they get an angle to it. They do the same thing in the reverse direction. And that's where they get the two angles. They get the reciprocal zenith angles by adding those together. If you watch that quick presentation, it's not a video. It's just shows how he did it, and everything you're asking for is in there. I can go on, but I'll get muted because he doesn't like me talking for a long time. So why don't you just open that link, and then you can see how it's done, and it's very clear. And you can see the pictures where he's actually making the measurements, and that's what you want to see, Bev.
Yeah,
and it can't. And these values that he gets are these about 16 to 17 arc seconds average of deviation. That is basically the reciprocal zenith angle excess that shows that it is not parallel. These plumb lines would not be parallel. Now, do you want me to post?
Oh my God!
The link, or should I read you the link?
You said reverse angle. What's the reverse angle?
Reciprocal zenith angles.
So, like, you posted at 57 past the hour a picture of a notebook.
Right.
What number one? There's two readings. What do you think is those? What do you think are those two readings?
They take the angles to the target from one station to the other, and then the other to the first station.
Well, first of all, you have to know how the.
So they have a GNSS receiver on stake 1, and the target on stake 2. That's how they do it.
So you think number one that you think that's
that little thing above the theodolite. When they actually take the measurement, they're sighting to that stake with the target from the theodolite. And then they have an angle. They do it backward. And that's how, so if they have angles to one and angles to the other, reverse, they add those angles together, they should add up to 180. And they're not.
Just to clarify, I just need a clarification. I'm just trying to be uber specific. So number one, there's two measurements. There's like an 89 and then a one, whatever it is. I can't read it. So the first reading is from A to B, and you think the second one is from B to A?
Correct.
Okay. That's all I needed.
Sure.
I want to make a point. Charles was nice enough to send us these instructions how to use the data light. And I looked through all the instructions. It talks about horizontal planes. Doesn't say anything about curving. Doesn't say anything about a triangle more than 180 degrees. It's just horizontal planes. It's very clear. So what the hell are you guys doing?
All I was going to, I just wanted that clarification from Zanuck because George would totally disagree with you.
He's saying he went from one spot and just measured one angle to the same height station on the other side of the lake. The GNSS sensor, the receiver.
If you're that ignorant about those measurements, I don't even want to really
I'm telling
correct
you. Do you not agree that the target set on stake 4 and the GNS receiver was set on stake 3?
I'm just talking about this was a measurement from point A to point B, and you think
from stake 1 to stake 2.
And you think that those two measurements are from at 1 is from A to B.
Why
and then
you
from
think
B
you
to
have got me, and you are so delusional.
Yeah,
not delusional.
They go from 1 and 2. They to 3 to 1 to 4 or 1 to 3 and 4 to 2. We go back and forth.
If we're looking at the book, it says he's got zenith angle, right? Is that what we're looking at here? The zenith angle?
The pencil stuff. The stuff he wrote down in pencil in a book.
Yes.
Struggling.
Zenith angle.
All 4 stakes were set to 26. Say one hit.
One's a horizontal angle and one's a vertical angle.
All 4 stakes were set to be within the worst case range of a ½ inch at the elevation of 26 feet. That's the elevation of this particular points. They both are 26.03 feet.
It
shows them mechanically setting up the with a pointer on the theodolite to that 1280 centimeters, I think, above the ground.
My only clarification question was to ask that top the one that you posted, set 1 zenith angle, you know, that little those set 1 88 degrees 11 minutes 28 seconds, and then 271 48 35. And I was asking you specifically, is the 88 11 28 from A to B, and is 271 from B to A?
No, the 88 is a zenith angle.
You're back to this. Do you not understand they use 2 theodolites? They got one on both sides of the lake.
He only had one. Don't be silly.
No, they have 2.
No, they didn't.
Yes, they do. I have a picture of it.
He moved it.
Hold on. The second theodolite set on stake 2, and the GNS receiver was set on stake 1. Second theodolite stake. There's 2 theodolite stakes.
All right, Zanuck. One question. Set 1 zenith angle. You got 2 measurements. How did he get those 2 measurements? I think you posted it. Did you put? Yeah, you posted that notebook thing. I'm asking Zanuck. Set 1 ZA. Those 2 angle measurements. How did he acquire those 2 measurements?
He doesn't know.
One's a horizontal angle, one's a vertical angle.
I didn't ask B-Ball, I asked Zanuck, and B-Ball, I will ask you now. B-Ball, how did set 1 ZA, how did he acquire those 2 angles?
He read this screen.
That's it.
That's my answer.
So you get the angle measurements in it. Can I just come in? Oh, thank you very much, B-Ball, for posting that picture. Can you remember when we came in here, Geo, and put a screen to show you guys what you could see over the auto level? Remember when we said it's not actual surveying, right? This is just an optics test, right? And when we came in here, we said, look here, right? Look at this. This is the 3 millimeters where you should be looking. Can you see 3 millimeters? Now, that's what we came here to do.
Yeah, we see that you created a horizontal plane, and that horizontal plane intersects
I've posted a picture there. Do you want me
be.
to post it again, just so everybody can see it? Right?
Yeah,
it
your
says,
horizontal plane is
says
intersecting.
1 arc second is 3 millimeters. Look here. Look here. We got everybody to do that, right, B-Ball?
We have 16 arc seconds. We're looking for.
Yeah, but your crosshairs are hitting a lot higher than they should.
No, they're not. Here's a picture.
Can you
look at the chat,
accurately place the crosshairs within 3 millimeters of a position?
Building, I see that.
Do you have the picture?
I know, you're doing exactly like you were meant to do, B-Ball. Can you see that on the measuring rod, you cannot measure to 3 millimeters? Can you see that?
Well, what I can see is that your crosses are hitting a lot higher than they should.
What do you mean a lot higher? Just look at the measuring rod, B-Ball. See there? Can you see to 3 millimeters?
Let me go down.
How close do you think you could get?
It's not a matter of higher, guys. It's a matter of getting an angle above the theodolite to the sensor above it.
It's a magic trick. Everyone can see it. It's right there. Right there. Everyone can see it.
So
yeah, we've seen it.
Just the fact that you guys don't know how he acquired those angles is baffling to me.
Well, maybe you should go find out.
I did.
If we're not
George,
giving it. If we're
George,
not giving you the right answer.
The late George.
Okay, go ahead. Lay it on us then. Tell us what they are. If you have the answers, go ahead.
I'm not telling you. George helped me figure it out.
Okay, great. Yeah, George doesn't believe the Earth is flat either, so he wouldn't agree with you there.
It's
he
not
helped me
flat.
figure out how the theodolite works. Obviously, you guys didn't talk to George.
Yeah, I talked to George. I didn't demean him and belittle him like you guys did.
We didn't.
Yeah, okay.
That's a blatant lie. from
Okay, right,
B-ball there.
right. Sure.
Hmm.
Oh, you
Because
guys, you guys treated
George
George with
actually,
so much respect. You
George
sure did.
actually, am I allowed to speak or are you just going to talk all over me? I was just going to say that actually we had quite a good conversation with George, and George was going to come and visit us in the UK when he came over to see Rumpus. Me and him were actually going to go out for dinner. But yes, we were really mean to him.
Yeah, you were.
Yes. According to Beeble, whose word should be taken for absolutely everything.
Yeah, you guys treated him with so much respect. I remember all the times you guys. Yeah.
We did.
Is this a bit like when you went on Red's channel and couldn't give any examples, you just talked shit?
When did I go on Red's channel?
Oh, it might have been the other one, Steve McRae, but Red's was on there. And you were just talking shit with no evidence. Is this the same thing?
I have plenty of evidence. The
Go on
Earth being
then.
a globe. If that's what you want, if that's
Oh
what you want to talk
no,
about.
we weren't talking about that. We were talking about your accusations.
What accusations did I make?
Do you not remember the last 3
No, go
minutes
ahead,
of this
fill me in, please.
conversation?
No, fill me in, please. What accusations did I make?
Okay, everybody has just seen what happened there. That is all I needed. Thank you, Beeble.
What accusations did I make? Okay, no one's gonna say. Okay, go ahead. Carry on.
Everybody knows, people.
What
There's
accusations did I
big
make?
magic trick happening that you can't even see yourself. We were the ones that talked to George. It's there in videos. You can actually watch the videos and listen to the way we talk to George. Everybody knows that you guys are just slandering us.
George Nutsack and all that stuff. That's real nice. You call him George Nutsack and all that. That's real respectful.
Yeah, here's the funny thing is that I'm live on a video with my confusion about how those measurements are made. And it was actually George and Bev like helping me figure out how they do those measurements, the angle measurements. But you guys, Zanuck, B-Ball, don't know. And it's obvious how they got.
So how about you go ahead and
those angles?
So how did he acquire the angles then? If you know, go ahead, fill us in.
He just wrote some numbers down in a book,
right?
And you guys took everything on. Yeah.
So he just made them up. So your claim is that he just made them up,
no,
right, Bev?
The claim is that he cannot measure that accurately from sighting. So you guys, why not? Because look at the fucking picture.
Have you gone out and tried?
3 millimeters in that fucking science, people. What can you see?
In this server, he went out purposefully to show that you cannot do that accurately. But you guys don't even know how he acquired those angles in the first place.
Bev, you used an auto level. You didn't use a theodolite.
It's got a better scope than he has.
Does an auto level measure zenith angles, Bev?
You don't even know how.
No, it doesn't.
It
doesn't. So no, you didn't do anything.
People. That's not relevant.
It is.
It's an optic test, B-Ball.
It is relevant. It's measuring a zenith angle. Okay. It's not.
He's trying to measure a horizontal. No, dude, he's trying to measure a horizontal. You're claiming he's shooting.
No, Gio, we're not measuring a horizontal, right? Putting a camera on the back of the auto level invalidates the tool for surveying purposes. Of course. This was an optic test to show people what you can see over 500 meters. Now, in order for you to accurately measure to an angle of a 1 arc second, you have to be within 3 millimeters, because that's what an arc second is over that distance. 3 millimeters. So we went out there to show people, B-Ball, that you cannot sight 2-3 millimeters over that distance. Right now, just the fact that there's a big Blackpool Tower in the background, right, does a magic trick to everyone, because they can't see the fact that they've been fooled by some guy writing down some numbers in a book So what they do is they switch that to the bigger picture. Let's just avoid that. We call it ECV, where people can't see what's right in front of them for the fear of realizing something. So that's what we went out there to do. And we've been telling everybody,
and
right?
when you did that,
Attaching a camera to the back of these tools invalidates the tool for surveying purposes.
I agree with that. Yeah.
I don't even know what you guys are talking about, but Bev seems to be the most rational person here. And
right.
I mean, I don't know, like really came into this conversation. I have no clue what you're talking about, but what he's trying to say is basically he's talking about correct measurements, and I don't hear any rebuttal to it.
I'm with Bev also, and since when did surveying tools measure Earth's curvature? Never. So
okay.
I don't know what you guys are talking about.
Earth, what is your response? Because could you enlighten me, like on what the conversation is about?
My response to what?
To Bev, to whatever, to this whole Discord.
To the guy. Okay, so first, let me go ahead and show you the picture what I was talking about, right? So if you look at the picture that Bev posted at 14 minutes past the hour, he's holding a measuring rod, and they're looking through an auto level, right? So that auto level is a specific distance above the ground, right? The crosshairs are hitting at a specific height above where he's holding, right?
No, it's leveled on the ground that he's at.
Right. Hold on. I'm not finished. So in the distance, you see that tower back there? The crosshairs are hitting at the top of that building, which is well above his elevation. So this is what he doesn't want you to see. This is what he doesn't want you to look at. Because when he took the picture,
that's where I made you look, people. I made you look there.
Talk over me.
You're laughing.
Talk all over me, right? So when he took the picture, right, he inadvertently showed that there's drop from horizontal. That's what he doesn't want to show. That's what he doesn't want you to look at. He wants you to say, well, you can't get millimeter accuracy from this distance because you can't read the measuring rod. Well, I don't have to read the measuring rod. I can see that tower is a specific height. The top of that building is a specific height. And wherever the crosses are hitting, they're hitting well above they should be if the Earth is planar or flat.
It begs the question,
and
though,
it's no,
like
and it can't be it can't be at a lower elevation because that would mean the building is underground.
You said you don't have to measure. Like, what did the main surveyor do?
You can't see the argument for the model.
I know. They don't even know what the main surveyor did, so it's like if they don't know what the main surveyor did, they won't know what you did. Like, Zanuck thinks that those measurements are like 89, and then the other one is like from A to B and B to A, and that's like
it's
totally
a different
wrong.
target. You don't have to have a theodolite at the other end. You have the theodolite target at the other end. You can have one theodolite. You have a theodolite target and that GPS receiver on the other side, GNSS receiver.
How did they get 1 arc second accuracy?
They didn't get 1 arc second accuracy. Where do you get that value from?
That's what the main surveyor got.
No, they didn't. No, they did not get 1 arc second.
Yes, he did, because that's what we went out there to show.
Average. Okay, the standard deviation was what? What was the standard deviation from the measurements that I showed you that I posted already? Do you know? Can you remember?
The individual measurements,
Zanuck.
What is it? Let's go back to the value I gave you. It wasn't 1 arc second. It wasn't 1 arc second. Let's go back to the values. I'll read them to you.
You don't even know how he got them, Zanuck.
The standard deviation.
Everybody knows that you don't know how they got them.
Hold on. The standard deviation, so by measuring multiple times for 4 full series, they had the reciprocal zenith angles being 17 seconds. Next series was 20 seconds. Next one was 13 seconds. Next one was 12.5 seconds. The mean was 16.2 with a standard deviation of 2.8 and a standard deviation of the mean of 1.4. So I don't know where you got 1 arc second. They're nowhere near that. Some were 17, some were 20, some were 13. There's like a 5 arc second difference, but the mean was 16.2 arc seconds total.
You don't even know how they got it.
What do you mean I don't know how they got it? What are you asking me?
How did they get that measurement, the angle measurement?
You want to know what those angle measurements are?
He thinks
How
he's holding
did-
some type of
If
card.
you,
I
if
think
you
you're
were
asking what
going
the
to
angle
go,
measurements
if you,
are.
He's
if
like
you
playing
were
poker.
Jesse Kozlowski or you were the main surveyor, what is the procedure they did to write those numbers down?
Oh, so you're asking about the 80 degree and the 275 or 265 or something. That's what you're asking for? What those values are?
How would you acquire those angles?
I would measure an angle. I'd measure a vertical and a deviation from vertical of the target.
Right.
That's what I would measure. And then I would add those values together and see if they add up to 180. That's how you get it. That's what it means. That's what reciprocal angle means.
Repeat it one more time.
You have something going from. So I have a vertical, and I look at a target, and it's a little less than 90 degrees. Then I measure the other direction. I don't have to actually go there. I can just take the reciprocal of that and find out what that reciprocal zenith angle would be, and then add those together and see if they're 180.
So Zenik, you know what they're doing? They're recording your voice so that they can go back and play it on their stream.
That's fine. I don't care. They can record my voice. That's how
That's
they
what
do
they
it.
do.
You have a greater than 180, greater than 190, greater than 190 one way.
It's on YouTube
and less than
live
190
right
the other way,
now.
and they add them together.
No, yeah, we know that.
No, but it doesn't matter. Like,
so what is your gripe about this, Buster? Like, what's the point?
Okay,
you're saying we're
Zanuck
incorrect
totally
about
failed.
how we got the measurements, right? So how about you go ahead and tell us? Since you're
Zanuck
correct.
totally failed. B-ball. I'm not going to say it because George helped me figure it out. I want you
Okay,
to
so go
explain
ahead,
how they got
go ahead.
that measurement.
You've asked several of us, right? Obviously, we're not giving you the answers you want. So go ahead and tell us, since you're holding the cards there, guy.
You guys are touting. I didn't post those numbers.
So go ahead and tell us. Go ahead and tell us, since we're all incorrect. Now, I'll go on mute. That way you can explain it.
I'm not explaining anything.
So go back to the. It was about plumb bobs, wasn't it? About sighting plumb bobs originally. I don't know how we ended up getting here.
Well, that gives you a vertical. A plumb bob only. They didn't use a plumb. They use a bubble level, and that gives you a vertical if you need to use the vertical zenith angle. Look at the zenith angle.
Bubble level. What?
The bubble level on the theodolite gives you the orientation of the theodolite, so it knows where horizontal is, and it gives you an angle.
Yeah, horizontal.
Horizontal, yes.
Yeah, fine.
Plane. Level.
Plane, yeah.
Level, horizontal. That's what the theodolite allows you to establish itself.
Did you just wait a minute? Did you just say level horizontal?
Level horizontal, yes.
Okay. Is level horizontal then?
Level is horizontal, yes.
He's talking about horizontal angle and vertical angle. That's what he's saying.
Horizontal is you establish level, and horizontal is the level direction. Remember I told you how level means a direction? It's out in the distance into infinity at that one point perpendicular to plumb. That is the direction.
Level is.
Now that hold on, that line is the horizontal. The level,
the level lines are horizontal.
But that level line is the horizontal. Yes. I hope you're recording this. The level line is the horizontal.
Yeah, but I mean, your words mean nothing, right? Everybody knows that. In
Well,
fact,
no, everyone
you're
knows it.
probably
Yeah,
invalidating
you
it
haven't
more
known
there
what
by you
level
saying
occur-
that.
By the way, I just-
Everybody heard Zanuck there, right?
I hope so.
Yeah. Level is horizontal, right?
The level line is a horizontal. Yes. But it's only level at one spot, right at that point, which is perpendicular
the
to plumb.
line. You
The line
can't
is
have a line at a
The
point,
level
right? You've
is
got
a
more than
line
one
that
line.
starts at the plumb line and goes out into infinity.
Mm-hmm.
That level line is horizontal.
Yeah.
The level, hold on, but there's only a level at one spot. It's only
What?
level at the plumb line.
The level line.
The level line is only level at level is a direction, Bev. This is what you haven't got for 4 years now.
And it goes out to
Level is only
infinity, the
direction.
same as horizontal,
It's an
right?
orientation.
Yeah,
it's an orientation.
horizontal.
Why do you talk over me every single time? It's perpendicular to plumb, Bev.
Yeah, horizontal.
The line is horizontal, yes.
Yes.
Yeah, perpendicular to plumb.
Yeah,
it's horizontal.
That's what we've been saying all along.
But it's only level at one spot.
The line.
Level, right? It's only level at the plumb line.
But the line, the level line, is only level.
It's a direction. You sit at this plumb line. You say, you know what? Which way is level? That way. And that way happens to be 90 degrees opposed to plumb. That's all it means, Bev. You're making too big a deal out of level.
So it's not at the point then, right? It's got to be in across the plane. Like
no, God no.
How can you say where it is? How can you point in a different direction if that point is where you are?
Because it's an orient.
That sounds fucking ridiculous.
To you, because you're
mentally troubled.
The day I met you, Bev,
it's the monad, obviously.
Wait, level is an orientation.
Let's back up.
Perpendicular to plumb. I don't know. I don't know why I have to explain it further than that.
Zanik, let's back up. Like you have an instrument, and you can level it. You could spin it right on a horizontal plane.
Yes.
Okay.
That horizontal plane is level at one spot at the theodolite.
It's perpendicular to plumb, right?
That one spot establishes a horizontal plane, if you will, as well, at one spot, which is perpendicular to plumb. Yes.
Yeah, perpendicular to plumb. So, like, you've got a crosshair in that instrument. So you could sight to another vertical, and it would line up. Correct?
You mean line up vertically or line up? What do you mean vertically?
Yeah, the vertical crosshair, like a plumb line.
You could sight the crosshairs to a vertical plumb line. Now, where on the plumb line would make all the difference in the world? And I'm telling you, the height above the surface would be higher, slightly higher. Now, they've actually measured this. That's what that Jesse Kozlowski's measurements are. They're looking at a target.
Let me ask you this.
Can I finish the sentence?
Yeah. Oh,
they look at a target. They look at the target, and then they measure the angle to that target that is the exact same height as the theodolite's measuring. So that means that when they measure that height of the target angularly, it'll be either plus or minus 0 level.
I almost thought for a minute there that you were actually done.
I know.
There's like 3 seconds of silence. Like, what was he actually done? Was he going to actually pass the mic?
You don't know how they got the measurement, but here's the thing. You've set your instrument up properly and you sight to a vertical. I mean, you've got a horizontal plane and it's perpendicular to plumb, and you've sighted to another plumb line. Now you have a vertical plane.
Yeah, the vertical plane is the same between the two.
There you go.
What do you mean, there you go? The problem is the point where I intersect the crosshairs, because they're crosshairs, they're horizontal and vertical.
Yeah,
that is higher on the plumb line, which is vertical. I have a vertical. The plumb line across the lake has a vertical. The point where I intersect that line, even though the vertical planes are aligned, the horizontal planes are not, because I'm looking at something that's above the height at which I'm viewing it from. That's where you get the reciprocal zenith angles that are going to be greater than 180. Because if I look at it and I look at that spot, if I look at the same spot, it's going to be greater than 90 or less than 90, depending on which way I look at it from. If it's on a hill, it'll be two different angles, right? And they both would be, one would be less than 90, that would be greater than 90. But if it's on a level surface, then I'll get something greater than 90 on both of them. One looking one way, one looking the other. They'd be greater.
Oh,
so the end would
don't do that. You'll ruin Blue Marbles Proposition 29.
Yeah.
Yeah. Yeah,
there's a reason they have a theodolite.
Don't ever turn around when you're doing that, Zanik. Just a note for next time, right? Word to the wise. Wink, wink, nudge, nudge. Don't ever look behind you.
Never flip the scope. Or turn the scope.
And B-ball, I hope you're still here, mate. If you think I didn't know, if I wasn't the one that purposely put your eyes on Blackpool Tower for a reason, what do you think that reason was? I think it might be able to show everybody the magic trick. You're looking for 3 millimeters on a measuring rod to help verify one of your shadow giants. But you can't see it. It's not there. It would get ruined. So what you have to do is you have to look at something else. Change your mind. Move it away to something else. Convince yourself of something that everybody knows. That you invalidate the tool for surveying purposes by putting a camera on it. And you'd know that if you'd ever tried to do a 2-peg test with the camera on and with the camera off. Maybe you've never tried to do a 2-peg test yourself. Maybe your shadow giant gods, priests, high priests aren't around to be able to show you how to do these sort of things. Maybe because they can't actually do that. It's like looking at a measuring rod for 3 millimeters over 500 meters, isn't it?
They still don't get that.
Made it go quiet again.
I'll give it away, B-ball, because George helped me. He flipped the scope. Zanuck, you flipped the scope. That's all I'm going to say.
Kosho's got a question for you, Bev.
Speak up, Kosho. Have I got him muted? I might have him muted. Let me check. No.
Well, that makes sense. That's why it's 271 and 88.
You flip the scope, Zanuck. It's not reciprocal. You just
That gives it a reciprocal.
No, it's just
that gives it the reciprocal zenith angle. Yes, because now you're doubling and checking upside down.
Instant expert.
You flip it around upside down. That's why you measure 271.
You know what reciprocal means, right, Zanuck? Don't you? Do you? I hope so.
You ever find a flat earther that did these measurements too, or no?
Pardon?
Yeah, that's why he did it in this server. Wasn't a flat earther though.
Yeah, I wasn't doing it for the flat earthers, guys.
But you didn't do this. You didn't follow the same methodology.
No, I just went out there to show you exactly what you can see.
Right, which doesn't have anything to do with this methodology.
No, that's all I'm doing. I'm just trying to let people see what's there right in front of them.
Why are you so insistent on tying it to the shape of the Earth?
That seems like a funny question to ask in this debate.
I don't know. And why do you think anyone that disagrees with you has to think the Earth is flat?
It's also a funny question.
Funny that you brought up.
Do you want to ask me like a good faith question?
Well, no, I'm curious. You keep using these words, and I'm curious about your use of them.
Which word should I use?
Did you? Is this a case of everybody forgets what they've just said?
I think so. ECV.
Yeah, because Negator, because you're the one saying that, Negator. That's the point. No, they're not. No one else is claiming those things. You're the one doing that. So why are you bringing that into it?
Well,
If we're talking about geometry and surveying,
we're in a debate about the shape of the Earth. That's the point.
It's not.
Not necessarily.
That's the point.
The problem.
The point is.
Yeah, the problem I have and that we have is that we've been telling you how to measure this for a decade.
To measure what?
And not a single flat earther has published his results showing us that our
I don't
methodology
care about flat
either
earthers.
is incorrect or reveals something other than a globe
They
Earth.
just have to avoid it all and bring it back to the shape of the
Deader,
Earth. That's
Deader,
all they can do.
What exactly am I avoiding, Deader? What would you like me to address? I'm sorry. I'll try again.
It's amazing.
Can I point out, right, that
No,
I came
Bev.
into this arena.
Had a comment,
I
and
came
asked her
into
a
this
question, and I'm waiting
arena
for her to
to
ask her
talk
question
to
again,
Jesse
because that's how
Kozlowski.
normal adult conversation
Because
goes.
that's where I came in.
When two adults speak, they speak
We're
to each
talking.
other.
All right.
Right?
Okay. I came into this because I was talking to Jesse Kozlowski purposely. This is specifically around the topic that I came into this arena, right? Like I've always said, I'm not a flat earther. It's just that some people assume certain things about people whenever they come into an arena. And all I've been doing is trying to follow why Jesse Kozlowski did certain things, because they're not standard practice. If you look back in the history of all of this stuff, there are only a few shadow giants. Yes, there are only a few shadow giants that do any of this. And Jesse and Jeff are a couple of the people. So I came here onto this server to show people
to me.
how they can see
things.
things.
Just monologue this entire time. It seems like you had something interesting you wanted to ask me.
About it.
Ditter. Is the question why I'm asking this? Is that the problem?
ECV, it was something about.
No, dead air. All of a sudden got a cat got your tongue now.
Yeah. Dead air.
What's this about?
Hey Bev, do you wear a headset or do you have speakers?
What do you mean?
Do you wear a headset or do you have speakers? Obviously, the implication
What's
is.
got to do with it? Just carry on doing whatever you're doing. I don't know. Are you harassing a woman or something? What are you okay?
No, because when people speak, it's almost like you don't hear them.
No, dude, you talked over him for 60% of the things he just said right there. You talked over him almost the whole time.
Because he wanted to talk to Emma, who obviously doesn't want to talk to him.
No, Emma asked him a question. That's why.
Yeah.
Yeah, but I mean, if he wants to respond, that's fine. And then if she wants to respond, she can. But I mean, you can't just talk over someone else because you just wanted her to speak instead of him. Like, it's an open panel.
Yeah, but I think Bev was the one that talked over Negator.
No, Negator said his thing. Bev then started speaking. Negator talked over him 60%, at least half of the time.
Because I think because Negator was trying to get her attention.
Yes, because he wanted my attention so badly. But it was we'd already made it clear that Negator didn't even remember what he'd said 5 seconds before. So there was no point in me continuing the conversation.
Okay. I guess you can, listen and then troll somebody else, I guess.
Disagreeing with you and asking you questions and pulling you up on points is trolling you. Okay. How do you deal with life?
What specifically do you disagree with me about?
Does everyone troll you in life when they ask you things?
What specifically do you disagree with me about?
No, we're on to something else now. As you well know, because you just started it.
Okay.
But it's okay. We can do this another time because there was more important things to be talked about.
Sure. What would you like to talk about?
Well, hold on. I just wanted to say the thing is, dude, is that there was multiple things Negator being talked about in terms of surveying, this equipment, geometry, horizontals, all those topics. But I think possibly what she was pointing out is that you kept trying to talk about a flat Earth, but there weren't arguments being placed forward about anything about relating to the term flat Earth. So I think she was just asking what you keep bringing it to that, even though those weren't the points being made.
So why are we making these points? Why do you think that is?
I don't know. You'd have to tell us yourself, whatever you're doing.
So if it's not about the shape of the earth, then what are we doing here?
Trying to show you guys that you might have been fooled by somebody.
In what way? Like,
in what
to
way?
what end?
Because somebody's telling you that they've done fantastic things, I'd say, and you are accepting of that.
Well, I mean, if I look at the guy's website, it's pretty damn extensive.
Wow, I've got a website too. You know.
What fantastic things are we being convinced of?
That somebody can actually cite to an arc second over vast distances.
It's called the filter authority.
Or that you can cite to a vertical and somebody else can cite to one.
You can't do it yourself. You're looking at other people with a lab code telling you shit.
So
Who should we appeal to then?
Hold on, you guys.
God-
Hold on. Buster just got talked over. Buster, you want to finish what you're saying?
Oh, just the fact that you can cite to a vertical, it's tilting away, and then somebody 90 degrees can cite to the same vertical and it's tilting away.
And you dispute this because you don't think an arc second is measurable. You do believe an arc minute's measurable. Why do you? What's the difference?
No, just the geometric principles are just thrown out the window.
Why is it when we go from measuring an arc minute to an arc second that we're throwing out geometric principles?
Well,
Which principle?
You're talking about measuring an angle on that vertical. That was a whole different topic. I was just bringing up one thing. That was like, and now you were diverting it to something else. Maybe on purpose. I don't know.
What am I? I thought I was diverting it to your entire point that we can't measure arc seconds.
Maybe it's just your geometric ignorance. I don't know.
What about my geometric ignorance makes it impossible to measure an arc second, but possible to measure an arc minute?
Well, on what plane are you what's the angle? What plane are you measuring the angle on?
That's not really the question. Does the plane matter? Are you suggesting that there's a plane out there that we can measure an arc second on, but not an arc minute, and vice versa?
What's the angular size of the crosshair?
I don't think that's Buster's argument, Bev.
No, I'm asking you. I'm asking you just to make sure we are understanding. What's the angular size of the crosshair?
Okay, that's fine. You can wait until Buster's done.
I was bringing up one point. That's a different one.
Mm-hmm.
That was like what we've been on for like the last 30 minutes. I don't know. And nobody knew how to answer the question, how they got the measurements. Like, that's another thing. Like, how do you guys not know how Jesse or the main surveyor got the measurements that they got? Do you know, Negator?
When you say how, like we've said it several times.
No, you didn't. Nobody answered it correctly. I had to give it. Now, let's see if you can repeat.
Wait. Well, hold up. Wait. You said you had to give it? You had to give the answer?
Yes. Nobody had the answer.
So
am I wrong?
Why?
Is anybody in this panel, did anybody ever answer how the main surveyor or Jesse got 1, 2, 3, and 4? The notebook measurements that they got, the angle.
No, I never heard a response, but you did ask him thoroughly enough times for them to respond.
He's being exceptionally dishonest here, Buster. This is not how grown men act. That's not what happened, okay? Please don't lie.
No, that's exactly what happened. Buster asked it many times. Nobody answered it except Buster. But I don't think you guys even heard it when Buster answered.
Well, don't you? It makes me question.
Still answered even after I gave you the answer. I still don't think you can answer the question.
Well, it makes me question your intent to have a good faith conversation when you spend 30 minutes supposedly asking a question that we didn't answer when you knew the answer all along, right? That's sort of the definition of a bad faith conversation.
No, I still don't think you can answer it even after I gave the answer in good faith.
Mm-hmm. And what's that got to do with the ability to measure an arc second over an arc minute?
It means, do you know how they acquired those measurements?
I do, yeah.
You do?
Mm-hmm.
Can you explain it?
But what's that got to do with the difference of measurement of an arc minute versus an arc second?
Means there are notebook measurements that are on record from the main surveyor that got an accuracy of an arc second over a certain distance. And nobody
They did.
knows
I
how
already
he
got.
acquired
I went
them.
over that already. There was no accuracy of 1 arc second. Why don't you understand that? I actually gave you the values, what they actually measured, and it was nowhere near an arc second.
Yeah.
Sometimes 5 to 10 arc seconds.
Well, he keeps changing the topic because
I
his
know,
initial
right?
problem was with the ability to measure an arc second. And anytime I
You
ask
don't-
you about that, you divert to, well, these measurements show something, but it has nothing to do with your question about whether it's possible to measure an arc second.
All right, is it possible?
I think it's possible. Do you think it's possible?
How did he do it?
No. That's not the question. Is it possible, Buster?
I don't think it's possible.
Why
I'm
not?
asking you that's the question. How did he do it to make it possible?
No. Why? It's the exact same method that you would measure an arc minute. You tell me what's different about the methodology in measuring an arc minute versus an arc second.
Well, it seems like that's a slightly different topic. He's just asking for validation of what you're claiming.
No, it's like asking, how do I measure a 16th of an inch when I know that I can measure a quarter inch?
No, wait.
Yeah, but what you can measure is different than what is being claimed. Those are
Wait,
separate topics.
but you and I both can validate measuring a quarter of an inch. Like everybody here knows how to measure a quarter. Well, I hope everybody knows how to read a rule, like quarter of an inch. The problem is that we see like these things posted all of the time about the main surveyor, Jesse Kozlowski, and the main one we got forever was the main surveyor and his measurements. And some of his notebook measurements were within an arc second, over 1,500 feet.
Okay.
But nobody knows how he acquired those measurements. If you can explain how he acquired those, feel free to explain.
Okay.
I think I told you he lines up the theodolite with that target, and that target is a specific height. And they get an angle from the theodolite to that target at the same exact height. And then if you want to, they flipped it around upside down to get another angle to verify whether that thing is accurately level, I guess. I don't know for sure. You seem to have found out from George and discussing this. We went over this 2 years ago, so I'm kind of going on memory. But anyway, that's how they got the angle. And the angle is not within 1 second. They had measurements that seemed to be well off of a second. Now, by chance, they could be with multiple measurements of the series could have been off by a second. But they took, I don't know, 30, 40 measurements, I believe, over the 4 sessions. So those were off by 5 to 10 arc seconds. And the average was 16 arc seconds.
Just
and
funny
that average is what gives you the vertical excess.
It's funny how you didn't know all of this stuff before, and I gave it
No,
to you.
I said
now
exactly.
You know.
The only thing I didn't know, they flipped it around. It's the only thing I didn't say differently
Is that,
than right
you know,
now.
when he
Go play
did
it back.
40 measurements, did he just keep flipping it? Is he like a flipping the thingy with Tourette's?
No, they set it up. They take a measurement. They wait, set up again, take the measurement again. Everything's done in succession. Multiple measurements. I think he did, I don't know, 5 or 6 measurements in one day. And then they went back the next day. Over 4 or 5 sessions, they took measurements, multiple measurements.
Over
I have
half
that
a mile
logbook too.
lake.
The
Half
problem,
a mile, yes.
The problem I have, Buster, is you're not explaining your problem very well. Right? Because it sounds like you have a problem with the accuracy of the device. Is that the problem?
Yeah, what did he flip the scope to?
Can I make a comment?
Sure, go ahead. I didn't have a point at all.
You said you made a bad analogy. You said I can measure a quarter inch, and how does that? By why can't I measure 16th of an inch? That's not correct, because an arc second, the number you have here, is 1/10,000. So, not a correct analogy. That's like saying, can I measure a 1/500th of an inch? That's what you're doing. So, nice try.
The analogy was to show a device that's capable of measuring several different units, some that are smaller than others, so an inch, a half inch, a quarter inch, a 16th of an inch. and comparing that to the theodolite, which is capable of measuring arc second, arc minute, and a degree, and then asking, why is it weird that it can measure in arc minute but not an arc second?
It's not about.
Likewise,
It's not about the
he's
angle. It's
questioning
about
your
the
accuracy,
distance.
right? Because
I don't
you have
know.
one
He hasn't
degree.
been very descriptive in what the problem is.
If you have 1 degree, right, and then the picture you posted with the mountains is 1 degree, and then 6217. That's 1/10,000 of a degree. 16217. Did I get it right? That's 1/10,000.
No. So one arc minute is a 60th of a degree, and 1 arc second is 1/3600ths of a degree.
3600.
Yeah.
Okay, so 1/3600ths of a degree. He's questioning the accuracy. I was close. He's questioning the accuracy of that. That's all. That's fair.
Okay, but that's how accurate the device is. It tells you to what degree, or rather, to what arc second you're measuring within.
Yeah, and didn't Danny just say you're off between 5 and 10 arc seconds? Just say that.
Well, hang
So
on. I don't.
you
Now
can't say
we're
1 arc seconds and then say that's curvature when that's the chance of error.
no. We're getting away from the actual problem that Buster
Yeah,
has.
the error is not as much as the actual measurement. The measurement is 16 arc seconds. We're saying 5 and 6 arc seconds on different measurements, but the mean, because we keep on doing, that's why you do these things and so they have statistical significance to what your measurements actually look like. That's why you do means and averaging and things. So we have this measurement that had a 16 arc seconds mean or average, and then the deviation was only 1.2 arc seconds based on all the measurements, all of them over 4 days.
But you're measuring 5 to 10 arc seconds.
1.2.
1.2 arc seconds. Over what? A quarter mile? What's that in feet?
How'd you get 0.2 of an arc second over that distance?
It's an average. It's statistics. They didn't measure 1.2. That's all the numbers added up, divided by the number would be, you know how to do the average? You add up the numbers, you add them all together, and you divide by the number of values you have, and you get an average. That was 1.2. They didn't measure 1.2. The measurement is...
It's a little bit dishonest, do you not think?
No,
to be able to measure angles like that you can't
talk over me.
actually measure, and then claim that you
So you
can
don't
tell
believe
the
it?
shape of something. That's what's I came in. It's a little bit dishonest, and I think you guys, knowing the accuracies that you deal with within this blue marble science arena, right? That you should be a little bit more keep a closer eye on some of the things that you're saying, or some of the things that your guys are saying. Cast a critical eye over it, man.
They didn't even know how they got the measurements in the first place. Nobody did.
I mean, we did. I don't know why you're just making things up, Buster. Are you
Nobody,
trolling us now?
You didn't answer it. Did you Negator? Did you answer how they got those measurements?
Yes, I told you. You got told several times.
I did. How? Can we could rewind that and you could show where you answered that question, how they got the measurements?
Yes.
Mm.
You're not very good at explaining yourself, Buster. So what actually is your problem? If you acknowledge the method that they got the measurements, and the device's ability to measure an arc second is not in dispute, or is it?
You explain how you get the accuracy that they got. Please explain how they got it, how they got those measurements, even after I've given it away.
Why, Buster? Are you sea lining me now? Just trying to waste my time.
See if you know how he got the measurements he got.
But asking me a question, which you know the answer to, doesn't move the conversation forward.
It moves it forward to know that you know how they got it.
I told you, we told you, they told you.
No.
What's the problem?
Nobody did. And you still
can't. So given that you know how, what is your problem with the measurement?
You still don't know how.
Oh my God. You're like trying to win some internet points here because you think you got me on this?
You still can't explain it, even after I gave it away.
You've been saying it this entire time, Buster, but this doesn't help your point that you don't believe these measurements are possible.
Bev came in this server. I was here to show the very thing that you don't know how they got the measurements, how you can't cite that, and you still don't know how to explain how he cited those measurements. So
you have a theodolite.
Joke's on you.
You look at the target. You measure this angle. The angle is listed there, and the series 1 through 4 showed 17, 20, looks like 15, and maybe 17 arc seconds. The mean was 16.2. The standard deviation was 2.8, and the standard deviation of the mean was 1.4. So the standard, these are they weren't measured. And you guys were laughing about, 1.4 arc seconds. How could you measure that? It's a deviation. It's a standard
You just
deviation
measured the
of the mean.
17. You just read out 17.
Yes. 17 arc seconds.
Yeah, so
or
that's
20 arc
to
seconds.
the arc second, right? That measurement is to the arc second.
Right. Yes.
Oh, well done.
Well
done. So he did.
Oh my God! Have you worked in a machine shop where you actually measure like the diameter of a cylinder wall or a piston diameter? You'll get a measurement and you'll do it again and do it again, and you'll write this statistically to find out what the actual diameter of your cylinder is.
Yeah, not over a half mile lake. You wouldn't do that.
Let me finish. Bev, what is wrong with you? I was talking and you
pointing
just
out your
rudely
sophistry.
interrupted me.
I know you carry on with
It's
your
not
script there,
sophistry.
Zanny. Go on, off
You make
go.
a measurement, you write them down, and you do it again, and you do it, multiple 10, 20 times. And the series of measurements ended up at 17.1. That was the average of all those measurements. The next day they did it, got 20.3. Then they got, looks like 15. Then they got 17.5. The average was 16.2. That's the average or the mean.
You don't even know how he got it.
Doesn't even know what it is that he's saying.
They got it by measuring the deviation from level horizontal from one theodolite. From the one theodolite, looking across to the GNSS sensor as well as the target that was at the exact same height as the theodolite. That's where they got the angle from.
No, you just add in angles to a straight line, right, Zanik? You do realize that.
What do you mean you're adding angles to a straight line?
You are. This is what your end game
what does that
is, right?
mean? No, what does that mean, adding angles to a straight line? I have a straight line, and it's above the target. We get an angle that deviates from the horizontal level at that point to the target, which
and that's
happens
reciprocated,
to be,
right?
Can I please? No, you need two angles for that to happen.
It's reciprocated is exactly what I said.
No, the reciprocal zenith angles, or you add them together, or you take maybe...
Yes, but you don't even seem to know what they are, Zanik. That's the point I think Buster's trying to say. You shouldn't be speaking for this, Zanik.
I'm
especially.
trying to have a normal conversation with someone who's not normal. Yes, you have an angle. This will be either less or greater than 90. It happens to be greater than 90.
Yeah, but I specifically asked how you acquire those angles, and
I told you
like this was like an hour and a half ago. I asked from like those measurements that are written down, are they from? Is one like from A to B, and then the other one from B to A? And you said yes, like you totally agreed with it without like knowing how the instrument works. Like that instrument, they cite to something. Flip the scope to, I don't even know, like whatever marker. That's like the whole thing we've been asking this whole time is what is the reference point of, like I said, flip the scope. Like that's only half of it. Like what are you flipping the scope to? And nobody even knew that you flipped the scope to get those readings. But I have George to thank for that.
Oh, okay, we got you.
That's a salient point when it comes to reciprocal zenith angles. You can get them two ways. You can get them from measuring from one short. Can I just finish? Can I finish, please? You can get them from measuring one side to the other and the other to the first side, or like you said, which I didn't know, they flipped it upside down just to make sure that there's no error in the measurement.
If you just Googled it,
it's level, and now they're going to that meter that shows a deviation from horizontal is now upside down and you're seeing the other side out the other direction. And that would give you another angle. And you add those two together, or you subtract one from the other because it's going to be something minus 360. That's where you get the 270 or something. 270 minus the 89 or 90, whatever that number is, that'll give you a number. And if that number is greater than 180, then you know you have some type of problem with a flat surface to that object.
Yeah, because straight lines have 180 degrees, don't they? Two right angles.
Oh my God, Bev, you're so like 2016. we're seeing an object that's below level. The only thing we turn the thing over for is to validate that there's not error in our measurement or that we leveled it incorrectly. If it's set up incorrectly, then that should be not a problem, not an issue. You can just do one measurement and see it is 16 arc seconds below level from my theodolite. Therefore, the Earth is round, and here's the diameter, here's the radius of the Earth based on that one measurement.
Whoa, dude, we're just measuring an angle, right?
Yeah,
they don't even that's know curvature because things are the same side.
You don't even know what the main surveyor did.
He hasn't got a clue.
I've already told you what he did.
You guys are touting main surveyor.
Even after you told me what you thought they did,
I
told you. Okay, forget it. Never mind.
Your sophistry is
I told you what you've done.
Terrible, Zanuck. Terrible. You are the worst.
They measure to a target. They get a deviation from level. That is the 83 or 84 degree, 86 to 86.7 or something degree number on the multiple measurements. By the way, they did 4 series, 5 measurements per day.
Wow.
And that one measurement, one measurement is something. That one measurement is something not 90 degrees. And then they turn it upside down as Buster said, and they get another measurement. And then they subtract that from 360 and then see what you get as far as this number that was, plus or minus above or below 180. And it's above 180.
Blue Marble Science Geodetic Surveying, because it's not a normal procedure, this. Like, you should point that out to everyone.
You should tag out letting a gator take over.
Just point that out to everybody. This is not
you
a
really have
typical
no leg to stand on as far as like talking
procedure.
down to people.
I don't.
Well, you don't. There's no reason for this.
Okay? So you could explain what the main surveyor Jessica
tell me.
did.
Tell me.
I'm not telling anybody. I've already given away too much as it is.
He doesn't know. He doesn't. Negator. He thinks he knows because they flipped this thing upside down and view it through the other direction, and therefore that gives him a leg up because it gives it's a whole different angle now versus horizontal because it's been reversed. That doesn't change the situation that all you're doing in essence is measuring a deviation from the horizontal, Bev. It's a level horizontal line that is not going to be the same for another object 400 yards away.
What would you call the line that is the shortest distance between those 2 points then?
A line between the two objects.
Yep.
Not horizontal though.
Well, what would you call it? The shortest distance.
A line. It should be a line to the object.
Shorter than a horizontal.
Shorter than technically it is shorter than horizontal, yes.
So what do you call a line that's shorter than a horizontal?
A line that's shorter than the horizontal.
Yeah.
There's no name for it. It's just a line.
No, because you just fucking made it up. It's in your mind, right? It doesn't exist. You can't add angles to a straight line.
This is where, you're just in the same mode you were when you first learned that level didn't mean straight.
You said it was horizontal.
You can have a level line. A level line just follows equipotential.
Forgot about that, Zanuck.
A level line is just some line that follows equipotential. That's in every surveying book around the world.
Yeah,
everyone knows it, but you.
At all points at right angles to it. Yeah, that's what equipotential surface is, right?
Zanuck's reached the end when he resorts to gaslighting.
Well, it's hard when you have these couple of people that are just so ignorant of what they're talking about.
Yeah,
Right.
obviously.
I told you that.
projection.
The
Yeah.
gator,
Wow.
the gator responds with actually a gaslighting technique.
No,
Well,
projection.
Bev, I told you that level. I don't think anyone disagree with me that level is an orientation perpendicular to plumb. If the Earth is round, that's a horizontal line. Yes.
Yes.
Yeah.
Exactly.
Great.
Like what were we saying?
Great.
Is there a shorter line than that?
Yes. Yes.
Right, okay.
The line
Go
that
on.
connects those two objects is a shorter line.
Okay.
Then a horizontal.
Shorter than a horizontal.
No, the horizontal line doesn't hit the target. It's not the line we're going to use.
I know. So there must be a shorter line then, right? Because as far as I know, whenever you do measurements for like rise over run, then the run is a horizontal distance and the rise is a vertical, right? There's no shorter distance along than the horizontal. But, I mean, obviously, yeah,
it's
probably.
not a horizontal.
It's
not a horizontal if it's a rise over run. Come on, don't be.
Rise over run, yeah. Obviously, everybody knows that the run is horizontal and the rise is vertical.
Oh, the run.
Yep. Oh, connection problems. They're trying to cut you off. They're trying to tell you something, Zanik.
No. So here's a rise over run. If I look at this object far enough away and it is far below the horizontal, the rise over run would be what? I'd be at the same elevation, but why is the horizontal not meet with the
Yeah, I think that's for the better.
to be a rise over run?
Does somebody else want to take over for Zanik?
No, you're not. Now you're.
I know nobody can because he's put everybody in a really bad position.
You've got yourself into a pickle.
Not me.
Because now we're talking about so a level line isn't a curved line. Is that what you're saying? So a level line can't be curved?
You just said it was horizontal.
No, I said a level line
is an orientation which is horizontal.
A level is an orientation, a direction, not a line.
Is horizontal.
And the line is horizontal.
Exactly.
So the horizontal is level.
Yes.
At that one point, it's horizontal at that one point. And it goes off into the distance. And if the surface is curved, it'll go higher than any object on the surface at the same height. So any object that you want to find out what a level line is there will not be on the same horizontal plane as the horizontal you started with. This is what you can't grasp for some reason.
I can't grasp. I definitely can't grasp a shorter than the horizontal. Definitely.
Because you don't think level line. Because you don't think level lines are curved, which they are. And all geodetic surveyors, or every surveyor, knows that all level lines are curved.
But didn't you just say it was horizontal? See, the ability of you to hold both of those, you don't think that might be a little bit of diletheism?
No.
Both views as being true, do you?
I'll do it again. Level is an orientation. Like, where is that line going? It's going this way. Which way is that? That direction. Hey, I think I swear to God I was talking, Buster.
Yeah.
That line is perpendicular to plumb. Okay. Goes off in the distance. But the direction is level.
Perpendicular to plumb.
Is it level anywhere else on that line? No. Only level at one spot on the line, Bev. Only horizontal.
Oh, have they cut him off?
What? No. We were being quiet.
Level is only a point on that line, that plumb line. That any other line perpendicular to plumb is established.
Point on the plumb line. That's on the vertical.
The plumb line is the vertical.
Yes.
The level line will be a line that is established a direction in all directions. That is, all directions start at that line, at plumb line, and all of them are perpendicular to plumb. It could be a plane, a horizontal plane. Now, it doesn't mean anywhere else on that plane is level. Just because it started out level doesn't mean it's level everywhere. It's only
vertical
level
and horizontal are perpendicular, right?
Pardon me?
Yeah,
horizontal and vertical are perpendicular,
this is
right?
his entire shtick. It's
horizontal,
yes,
and vertical are perpendicular. Yes.
Okay, and vertical is plumb, right?
Vertical is plumb.
Okay. Horizontal's a plane, and so is
Correct.
vertical.
Yes.
Okay. Now,
can be.
All perpendiculars to the horizontal plane, all of those perpendiculars, they'll be vertical, right?
What perpendiculars to the plane of the
horizontal plane. Yes.
Only at one spot.
Only at one spot, but you've got a vertical plane and a horizontal plane, right?
Correct. Go off into infinity. That plane goes off
both
into
of those
every direction.
Okay, so both of those are perpendicular to each other, and they are, as you would imagine, planes.
Only at one spot, at one vertical line.
Where? On the vertical plane.
Plumb line. The plumb line.
Okay, so where's the vertical plane then?
There's infinite vertical planes. There's one line vertical. There's a horizontal plane, not a vertical plane. You could establish a vertical plane, but we're not speaking.
Of course, you can have vertical planes.
What I mean is, you don't have a vertical.
Vertical's a plane, though, right? Isn't it?
You could make a vertical plane, but that gets a little confusing because we have a vertical line. Hold on. Let me be clear. Let me be very clear. No, there's a vertical line.
Whoa, Zanik. Does anybody want to take over from Zanik?
I was going to say,
he's broken.
Yeah, it's rough, Zanik. You're kind of just talking nonstop. You're kind of going in circles. If you're going to try to say something concise, you got to say it and pass the mic, because otherwise it's just you're just running all over the place.
Well, he's trying to obfuscate the point by talking about vertical planes. Yeah, there could be a vertical plane between two plumb lines. Doesn't mean that those two plumb lines have a horizontal that is perpendicular to plumb that are on the same plane. They're not.
What?
You can have two vertical planes?
Oh God.
No, you have one vertical plane between two plumb lines, for example.
You said you could have two
they could be on the
same
plane. Yeah, same horizontals, however, are not on the same plane.
Wow.
Oh, it's breaking up.
Yeah.
Their horizontals, their particular horizontals, their level planes are not on the same plane.
So what about the verticals then? Are they parallel on the vertical plane? Or can we not have vertical planes anymore because we can't have verticals that are parallel on a vertical plane? Are we allowed to have vertical planes?
They're not parallel, but they can be on the vertical plane. Why would they have to be parallel if they're on the vertical plane? The vertical plane is just a plane.
The verticals in a vertical plane aren't parallel now.
No, of course not.
Okay. Wow, of course not.
If I have a telephone pole that was knocked to a 45-degree angle, and I have a straight up vertical plane, as I look down from one to the other, but they're not parallel. One is angling away from me.
Come on.
So they're on the same vertical plane, but they're on the same vertical plane because I can see them. In fact, if I had them right in line, I wouldn't be able to see the one that's leaning away from me because it'd be blocked by the ones in front of me. But it's on the same vertical plane, even though it's angling away. Now, if I look from the side,
the verticals on a vertical plane would have to be angling away from each other, would they?
Well, if it's going to be the same vertical plane, how would it stay on the vertical plane if it wasn't? If it was angled to the left or the right, it wouldn't be on the same vertical plane.
Okay, so could you place a horizontal line, right, in between two of those verticals?
What?
Could you
place a horizontal line? Okay.
Yeah, let's just imagine two verticals and a horizontal.
Okay.
Okay. Now, is there any chance of us having a perpendicular relationship between vertical and horizontal?
Well, now we're looking two verticals.
Yeah, two verticals on a vertical plane and one horizontal being placed.
Those two verticals will not share a parallel horizontal plane.
Okay, that's exactly where your angles have come from, isn't it? Your extra angles.
No, they do not. That's why we have the excess angles. That's why we have that's why we have the reciprocal zenith angles that are greater than 180, because they can't have the same. They cannot be in the same. They cannot share the same plane, nor can they be parallel to the same one plane.
Yeah. Some people might say though that you can't actually have that horizontal line in between the two. You know, that gets really complicated, doesn't it?
No, it's not. You can't have the horizontal line is more direction. You have a horizontal that's established from a vertical. That is a direction that starts from one point that was perpendicular to plumb. Anywhere else on that particular horizontal, if you drop the vertical, would not be perpendicular anymore. So you could say that it's only level at one point. And that's the accurate
But it's a line,
way to
right?
describe that.
That's the problem,
It's
isn't
a
it?
line.
How
It's
can
a
you
line
have a
that's
line
only.
at a point?
It's a line that's only perpendicular at one point. It's a line, though.
But
You're right.
perpendicular is a line.
No, perpendicular is
no. Perpendicular is the relationship between a straight line and another straight line, right?
right. Sure.
Okay,
But it's
so
only
you have both, right? You have both lines. They're the same line, really.
No, they're not.
They are. And they have the relationship of perpendicular. That's how Euclidean geometry
Perpendicular only
works,
means 90
right?
degrees.
Just
and 90 degrees is an
geometry,
angle.
really. Everybody knows that.
Okay. Well, 90 degrees is the angle that's
the
from
right
the
angle.
vertical.
Yes.
The right angle is
Vertical
from that
to horizontal.
Why when I start talking do you talk over me? Three times in a row you just did it.
I think I've got a thing.
You just did it 3 times in a row. Can you just not do it this for a second? This kind of gives me a headache.
Okay.
So you got a vertical, you got a horizontal, you got a level line that's a horizontal. It's only level and horizontal at one point on that vertical line. That's it.
Okay.
The only place ever on that particular plane or line that's going to be. I could have sworn I'm still talking.
I know, but everybody else, at least everybody can have a picture of what's actually going on here now at the minute. It's in the chat.
Okay.
Somebody posted it earlier. Reciprocal zenith angles. Right, and what we're doing is we're talking about these two red lines, the verticals on a vertical plane, as Zanik says. And we're talking about the blue line being horizontal, right? Orientating that one line horizontal. And what would occur? Like, how could you possibly do it? Is it possible that you could have two verticals and one horizontal having a relationship on, this imagined model? So, Zanik, that's what you're talking about, right? That's one line being horizontal.
You asked me a question and you start talking over me again. Let me talk.
Okay, go
That line is in no way, shape, or form horizontal.
I know. In the picture it isn't. We're talking about making it horizontal.
No, they don't want to make it horizontal. They don't care if it's horizontal. All they care about is the angle.
We are talking in this imagined thing that we're doing about a vertical plane and two verticals that you just said on a vertical plane, and then adding a horizontal to those verticals on a vertical plane, which I think it's neatly presented in this drawing. I hope everybody's got it in their mind and looking at it.
I understand what you're saying.
So the blue line, orientate that horizontally and put it in the picture.
You don't need to.
It'd only be horizontal at the middle.
It's not possible to, is it?
It's not possible. Nope.
No.
Impossible.
So you can't have two vertical lines drawn on a piece of paper, like a vertical plane, and draw one horizontal. It's not possible, is it?
But it's possible to draw a line between the two, right?
Yeah, obviously.
Okay. And is it possible to measure the angle between that line and the two verticals? Is that possible?
Absolutely. Horizontal and vertical are perpendicular.
No. Don't play word games with me.
It's not a word game. That's just a basic fact. Don't be trying to gaslight everybody.
No.
Saying that vertical and horizontal being perpendicular is word games.
I know. Don't play word games, Bev. Come on, dude. Like act grown, okay?
Let's go along with your sophistry for a moment and pretend that saying that horizontal and vertical are perpendicular might be some sort of trickery of the word.
I didn't say that. I just asked if you could measure a line that intersected both verticals, and you said yes.
You could establish a horizontal plane, yeah.
Nope. Can you measure a line? Can you draw a line between the two? Is that possible?
Yes, to prove that a straight line lies within a plane. Absolutely, yes.
Mm-hmm. And it's possible to measure the angle between your vertical, my vertical, and that line?
Vertical and horizontal are perpendicular.
Nope. Didn't say horizontal. I just said a line. Come on, Bev.
Well, I did say that vertical and horizontal are perpendicular, yes.
Right. But we're not talking about horizontals. Bev, yes. It's telling to me and the entire audience that you continue to throw in the word horizontal. I know why you're doing it. The intelligent people here know why you're doing it. And you know why you're doing it. And what I'm asking you to do is please be honest and just stop.
Keeping it in the realm of everybody to be able to understand, right? Everybody can understand that vertical and horizontal are perpendicular. That's our starting off bracket. So off we go.
Negator, hold on. You can't just You can't control what he's saying, dude. Just say your point. Let him say his. You can't just control everything he says.
Well, the reason he's doing it is to give himself an out. He's doing it to play word games, Geo. He's effectively being dishonest in the slyest of ways in this conversation by throwing the word horizontal in.
Well, wait a minute though. That's not fair because I asked about measuring that same angle, and you're saying, can you measure that angle? But nobody ever spoke up how you measure that angle.
We did, but the question, Buster, is can you?
You didn't.
Not can Negator explain it to you, right?
No, that was the question, is that anybody could explain how you measure that angle.
Well, now we're changing. It seems like you sensed that Bev has his back to the wall. Now you have to jump in and save him. Is that right?
No.
Yes. Save me, Buster.
Oh,
Negator's asked me a really tricky question.
Oh.
I can't even remember what it was, to be honest.
It is a nice show of their tactics, though, for everybody. So
got someone else
good
jumping
job,
in.
Negator.
See, we got the whole peanut gallery here. So now that we've agreed,
it was a little bizarre. You went on about word games, but you were doing a word game while you were talking about word games, and not actually responding to the point at hand.
Well, if you notice, Gio, I was the one that asked the question that he didn't respond to, but you didn't catch that.
No, he did respond. He was saying yes. He was clarifying. No, there was no.
No, Gio, did he answer? I can measure the angle between the two verticals in the line, or did he answer? Can I establish a horizontal at each vertical? Which one was it?
It's the loss of the vertical plane. It's hard work, isn't it? Can you imagine that, losing a vertical plane out of arguments? How did you end up here?
I can't.
So if we were to measure this line between the two verticals, how would and we got more than 180 as the
is that
the
a line on a vertical plane?
It intersects the two vertical lines that represent each individual's vertical.
So a vertical plane or not a vertical plane?
Doesn't need to be clarified.
I would think it should be, shouldn't it?
No.
No. Wow.
So now that we all agree that angle, those two angles can be measured. What do we do next?
You have to measure an angle within a plane, though, right?
Well, you keep saying that, and obviously we're talking about measuring off the vertical, using that as our baseline. But for some reason, you keep going back to measuring off a plane, as if I hadn't said we're measuring off a vertical. Do you understand that we're measuring off a vertical?
Vertical plane, yeah. You're measuring an angle within a vertical plane. That's what you're talking about. So everybody can keep an understanding, right?
And how do you think we do that? Like if we were to set it up and execute that, how would we do that?
Are we, like when we reciprocate it, are we measuring the same or a different angle in the same vertical plane?
There you go. You keep throwing extra words in that aren't necessary. The express purpose of obfuscating what's going on.
I'm not obfuscating. I'm just trying to clarify. So
what exactly are you trying to clarify,
in their mind of what exactly you're doing when you're measuring this angle on a vertical plane from point A, and then you go into point B and measuring an angle in a vertical plane. It's the same vertical plane that you're measuring that angle in, isn't it?
You keep throwing the word plane out there. No, we've established vertical for each device. That vertical is a line, and then we're measuring the angle between that line and the line of sight between me and the other object.
Okay, so not
you throw plane in. Then. You could throw it in, take it out. It's up to you.
A
but it's not
vertical angle is a vertical angle within the vertical plane, right?
Doesn't matter.
Yeah, I think it does.
No,
it doesn't. Dawn's coming to help.
You don't get to apply planes to everything hypothetically just to make your word game work. That's not how reality works. Sorry.
Really?
Yep.
Okay.
That's exactly what he's doing.
I would beg to differ. Like planes do matter because
no,
they kind of do because like there's plane views of.
Oh come
on! It's a plumb, a vertical line. That's how you get the angle. You're not imagining a big wall, a visible wall across the universe. No one does that.
Yeah, they do, and like the field I work in, they do.
No.
So you don't believe? Have you lost your belief in vertical and horizontal planes, Dawn?
When you say the word, it makes me feel sick inside.
I bet it does.
I know you don't care what it means. It's
What,
just
a vertical
word
plane or a horizontal plane?
He keeps throwing that in.
Yes,
just
I
because
do.
he knows that's the only out.
How is
Well,
that going to
yeah.
help you measure Earth, Bev? How is knowing about an invisible plane going to help you measure Earth?
That's just the basis of all measurements, right?
No.
Yeah, I think so.
Shared vertical plane segments.
I'm afraid not. No.
How about that?
You can measure stuff easily with never considering any planes.
No planes. Dawn, no planes.
No planes. The dawn are gone. Planeless dawn are gone.
Oh, the dawn are gone.
Look at that. What's that going to be like? Imagine that.
The man, the
Tell
myth, the legend.
tell that to all the planar surveying, Don. See how far you get.
Well, it's not exactly relevant to the question at hand, though, Gio.
What
did say
shape
it,
do they
though,
claim
didn't he?
Earth is, Gio? Do they claim it's an Earth? A globe? Globe Earth.
It's got nothing to do with that. They just survey the land, right? They don't. They make no claims. There's only a few, strange few, blue marble science geodetic surveyors that actually perform these procedures that you guys sort of have considered shadow giants for quite a while.
What are you talking about?
Just people being fooled, right?
You just said that it's only blue marble science that does these special globes.
Blue marble science geodetic surveyors. Right, blue marble science, as in the big capital S. They claimed.
You mean real surveyors? Who do it?
No. I'm talking.
He's not learned. Bev, he's not learned. He doesn't know about Plato.
How dare you?
Dawn, shadow giants.
What shadow giants? What?
You never read
the
Plato?
shadows on the
The
wall.
Republic?
You're trying to say that real geodetic surveyors that claim it's a globe and find drops.
They don't.
And stuff, you're saying they don't?
Yeah, they don't.
A minute ago, you said they were. You said
No,
only
only Jesse Kozlowski, no longer around. He's gone somewhere. I don't think he's ever going to return. The guy who probably doesn't live in Maine, that actor, he's not around here anymore. He's another one. The only one that's left is Larry Scott. And Larry Scott has told my son that triangles have more than 180 degrees.
They can.
They can't.
They can. On the surface of a sphere, they can.
They can't.
That's why they're called
spheres. Can't do magic, Dawn. I know
triangles.
you're into your witches and all that sort of shit.
Are you claiming
spheres don't do magic?
Hang on, dude. Are you claiming there's only 3 people on Earth that try and do surveying to prove Earth's a globe?
I would say so, yes.
You're insane.
Right.
I'm telling you, there's hundreds of real surveyors
Absolutely.
that know it's a globe that do it.
Yeah, everybody knows it's a real globe, yes. Everybody lives in the real world, Dawn.
So I don't care what surveyors using invisible planes. If they agree it's a globe, it's not an argument against me denying planes, is it?
As long as they agree with you, that's fine.
I came in, Don, like 3 hours ago saying that I watched surveyors for 8 years sight to plumb lines.
What?
Is that not a vertical plane?
What are you talking about? How does it make the Earth flat?
I didn't say the Earth was flat. I just said
why
that surveyors.
Are you trying to teach me geometry?
Because, like, that's logical.
I probably know geometry better than you, but you're still trying to teach it to me.
No, I was just saying that surveyors use geometric principles.
Who cares what they use? If they say it's a globe as well, all they're claiming is there's some mountains on this bit of the globe. Who cares what they say?
Yeah.
Who cares?
Yeah, who cares?
Yeah, Don, who cares?
You know, if you draw a circle, Don, can you say that's a vertical plane?
What do you want? What have you decided?
Could you give it a
vertical
center
plane
and
is?
say then call it a vertical plane, as long as it's got
What
a
is
center
what is a
somewhere.
vertical plane in your mind?
A vertical plane is a plane, a two-dimensional construct mathematically in the vertical position.
What's vertical?
What's vertical? It's perpendicular to horizontal.
And so that only works on a flat Earth, or does that work on a globe as well?
It works in reality, right?
Does it work on
all
both models?
I don't care about your models.
No,
it
I'm
works
asking you.
in reality.
Does it work technically on both models, the horizontal bit?
I don't give a shit about your models. Dawn.
If you're not sure, it's not going to be a very good argument for Earth being flat, is it?
I don't have an argument. You can't argue that Earth's flat because it's obviously not flat, Dawn.
You know what I mean by flat.
I don't know what you mean by flat, right, Dawn? Because you
don't
don't have a vertical plane. Your idea of a vertical plane is a circle.
Your idea of vertical plane is based on Earth being flat.
It's
Massive,
not.
Hypothetical
It's
horizontal.
based on reality.
Hypothetical horizontal.
Don, you are strawmanning. You're strawmanning right now. He didn't say those things.
I live in reality, Dawn.
If he has no claims, I'm going to claim victory on the debate.
Well done.
No, he said the things he said. You're saying other things and trying to make him say things he didn't say.
Yeah, I'm trying to make him make a claim because he hasn't yet.
He just horizontal and vertical are perpendicular, and they are planes.
Does it work on a globe and a flat Earth?
It works on the real globe, Dawn.
Does it work on the real flat Earth?
I haven't got a clue.
Okay, then it's not a very good argument for
only in reality is the only place I can check any of these things, and it works in reality.
If your logic can't fit the flat Earth, it probably proves a globe Earth.
You're obsessed, Dawn. Don't give a shit about your models. There is only one reality, and we all live in it, hopefully. Or some of us may be,
What are you claiming about this one reality?
That horizontal and vertical are perpendicular and plane.
Okay, I'll give you it.
It represented perfectly by geometry.
I'll give you it sometimes, hypothetically, in the math. That might not relate to the surface of Earth.
The geometry is the math.
Did you hear me properly? Did you hear what I said properly? That might not relate to the Earth's surface at all.
But if you can stand on the Earth and do it, then that's the geometry precedes the Earth shape. It's just that
right. If you
he's pre-assuming a horizontal is going to fit towards Earth's surface all the way along.
Dawn, please.
No, yeah, like
or he's going to assume that his vertical is perpendicular to the whole of the Earth's surface. That's what he's assuming now.
No, that's how it's not, because that's how you get elevation change. But the geometric principles still stand. Like that's how you find elevation change.
Yeah, but how are you going to relate it to Earth being either horizontal or curved?
No, you use the horizontal to find the elevation change.
Right. Have you found not just elevation change, but drop in the surface from horizontal?
That's the elevation change.
No, I'm afraid not.
Well, how do you differentiate? How do you differentiate
if Bev
between
agrees.
elevation change and curvature?
Easily. See if Bev agrees with you on that. Bev, is drop from horizontal the same as elevation change on a globe?
On the real globe?
On the globe model.
How you measure elevation change in reality is by measuring a change from a horizontal plane.
But
is the vertical change
is the
on
curve
a vertical
of the Earth,
datum?
Is the curve of the Earth the same as elevation on the globe model?
All of them are measured on a vertical datum. Dawn.
Just answer the question, Bev.
What?
Huh? I didn't even realise.
I don't know what you're talking about, Dawn. You're mental. You're obviously obsessed with a model. You can't get you can't get your mind off it. Like literally obsessed. I'm talking about reality.
You be quiet now. Buster. Elevation and drop from horizontal, the globe curve surface are different things on our model. Two different things. Curvature of Earth is not elevation change.
You can't get your mind off it, Dawn.
I asked you how you differentiate them, but you just repeated back that it's different, and you didn't explain how they're different. So it's still on you.
One is the curved surface of the Earth. One is sticking up and down above sea level.
What? Say that one more time.
One is the curved surface of a ball Earth. One is Earth sticking up or below sea level on the surface. Two different things.
Okay. You still have geometric principles at play here, that you have a horizontal
not always.
and you have a vertical change that's elevation, and you still haven't differentiated.
His vertical plane's different.
I don't stick to your geometric principles because I don't think they're true.
Well, then what geometric principles do you stand by?
I don't really.
Well, then you have nothing to stand on.
I apply
So
math
you
and
talking
geometry to
is irrelevant.
reality.
Your talking is irrelevant if you have no geometric principles to stand on.
No, that's bullshit.
How?
Don, are you just like going into solipsism now?
No,
Like,
I'm saying
you
that
can't
their
know
logic,
anything and nothing's real. I mean, is that where you're going?
their logic doesn't apply to me working out what shape Earth is. They want geometric principles to be like Moses' law, and I'm saying not for me, thanks. No.
Who said that?
Well, if you have geometry, you then have the Earth that is within the geometry. So just because the soil does what it does,
but
the geometry precedes anything that's relating to the soil.
Let me apply their geometry principles to my globe. Vertical is straight up from horizontal, yeah? Then you go round a quarter of the globe, you're now on the side. That vertical is no longer perpendicular to your horizontal. It's only perpendicular to the other horizontal you did before. So their geometric principles breaks down because Earth's a globe, if it's a globe, straight away.
Yeah, that's like begging the question at the worst possible analogy.
You're begging the question, saying that your principles have to.
No, you're
continue
saying that
to
one
to fit
person's
Earth.
horizontal is another person's vertical, and that's like the worst begging the question you could ever.
Well,
make.
let's forget geometry and go back to logical proofs. that
Yeah,
Earth's a
forget
globe, shall we?
geometry, forget logic. Like, let's just start from nothing.
I'm
and
saying
talk
let's use
nonsense.
logic.
No,
but let's
you
forget geometry.
can't forget geometry and go to logic, right?
Why not?
Because geometry is the foundation of logic. It tells you what is
Is it
true.
fuck? Is it fuck?
Absolutely, it is. They're the arguments you
Sorry,
can't
I'm out.
defeat.
If geometry is the foundation of logic, I'm out.
Yeah, geometry teachers
See
will
ya.
tell you it's proof on proof on proof on proof on proof on proof, and I don't think anybody would dispute that.
No one. Except a few people, like Dawn, who want to redefine perpendicularity. I think there's only one person that's ever put perpendicularity into a song.
That's true.
He's here right now.
Did you just make Dawn leave after he
I
said
hope
in
so.
the text chat he was going to destroy you?
Yeah. Well, that's, watch the videos titled with Dawn on Try Thinking channel. Eye-opening. Not made everyone go quiet again, have we? Sorry, Dawn. No offense meant, but
He said he
everybody
couldn't.
does know that, right? That geometry are the arguments that are left that cannot be defeated by sophists.
Yeah, he said he just said he couldn't take geometry and logic, and he left.
Yeah. He couldn't take geometry being the foundation of logic. It's a history book, a record book of logic that cannot be beaten.
That's one of the best proofs there is for our realm, bro.
It's just
there's nothing
reality,
that they
mate.
can say to overcome that.
Always, people have a clouded mind by models and arguments that have been given to them. Obviously. I think that's been on display. Right, Ruhif?
Sure, Bev.
Convincing people of geometric inadequacies. Little tricks that you can do. It's not really clever, is it? You want to advise people against attempting trickery with geometric principles.
Mm-hmm.
Do you have a vertical plane? You know, when you measure a vertical angle,
Sure.
is that on a vertical plane?
Who are you asking?
Anyone? What do you reckon? Is anyone brave enough?
Yeah, it's kind of where it left with Don. Don wasn't able to actually support that, so he kind of left. I mean, he was making the claims of the model, but he didn't have any way to actually show that in reality, of course.
Well, I can carry on. I'll try and relax, but I've searched up and geometry relies on logic, not the other way around.
Yes, I said it's the perfect logic. The arguments that cannot be beat by sophists.
Unless you include the globe Earth reality.
There you go. They wouldn't
Indeed.
happen to be sophists, would they? Very good sophists, possibly. With a neat magic trick. Hey, Ruhif.
What's the magic? What's the magic?
An angle magic trick. Ruhif will tell you all about it.
Well, you claimed they did a magic trick, so you explain it.
I think they try and add more angles to a straight line, but they do it through triangles, amazingly.
What does that mean? Trying to add more angles to a straight line. What does that mean?
No, Zanuck tried it a little bit earlier, didn't he?
Algorithm.
Here you go. Look. Logic serves as the foundation for geometry. Why are you saying it the other way round when you're talking to me?
I'm saying geometry is the perfect logic. That's the vault of all of the proofs.
But it's not the foundation of logic, is it?
It's the if you want to know how logic works, you study geometry.
You don't have to.
Oh my god.
It's one type of logic. It's not the foundation of logic. So as long as you get that into your head, you might be correct next time.
Okay.
So you do agree with geometry?
Sometimes I use it a little bit, but I don't agree you can apply it and mean the whole Earth matches it.
That's what geometry is. Earth
No,
measure.
it isn't. It's the study of shapes and 2D
Where
hypotheticals.
The
math.
name came from. Earth measure.
Yeah, maybe to start with.
But it morphed into something different.
Geography, geometry is similar, but they're different.
Mind tricks, right? Just an angle away. Like a rumpus pole in the distance.
Don't know what that means. Sorry.
I know you don't.
So this is kind of on topic, but I just found this paragraph describing Google Earth.
Brilliant.
Google
We're not
Earth
really
is a
talking about the Earth, you know.
No, but I know, but your conversations get a bit circular. So I was just going to look at this. Onto a 3D globe. They're admitting they just superimposed the data onto a 3D globe. So it's over.
Okay, that's flat. Well done, Blah.
That's offensive, that, to call it 3D.
Yeah, you can't call anything spherical.
Can't.
How would you make a globe Earth, Bartek?
Wait,
Google,
what's
Google
that?
Earth.
Don't you know that it's 2D? Right, you can't. Like, I know Ruhif was calling you a flat earther, but he's calling you that because you said it was 3D. Imagine that. Can you imagine somebody calling you a flat earther because you said the globe is 3D?
Me?
No.
I've never said that to Dawn.
No, you didn't say it to Dawn. You said it to somebody else. You called him.
To me.
It is 3D, but
No.
You're not Dawn, are you?
No, I'm an anti-glober.
Yeah, that's what I mean.
Now-
Like, he's just called you a flat earther because you said the globe was 3D. And actually, you tell him, Ruhif, it's 2D, isn't it?
What are you talking
I'm
about?
just telling
This
you.
is 2D, Bev.
Tell him. It's 2D, isn't it?
What did you say,
surfaces are
Ruhif?
2D.
It's 2D?
Yeah, all surfaces are
The
2D.
surface is 2D.
Yeah, there you go.
What?
They can be.
He's not a flat
Doesn't
earther, though.
mean
Don't
they're
worry.
2D.
Like, he's calling you a flat earther, but he's definitely not a flat earther because he thinks the globe's
Okay,
2D.
I better clarify. I posted the paragraph in the text, right?
Yeah.
Now, they're openly admitting they're superimposing images, aerial photography, GIS data onto a 3D globe. So it's all flat representations, right? But they're just using an algorithm to make it.
Yeah,
to
it's
make
not
it
flat.
look
It's definitely not
round.
flat, right? Nobody's saying it's flat.
What
What he's saying is that that's what they're doing.
No, well, there's
Yeah, so they're admitting that the Earth is flat. So I don't understand.
They're not admitting it's flat. They just
Where are
said
they admitting
had to-
that?
2D, isn't
they had
it?
to
You
take
tell
small
him.
photos
It's 2D.
and add them together. That's all they said.
You can't have a 3D globe.
But they have to. They're adding it to a 3D globe. What
No,
does that
you
even
can't
mean?
have a 3D globe. That doesn't exist.
Yes, you can.
Could you not
You can
project
have-
a
you can
3D
have the
globe
real
onto a
globe.
3D globe? You could project a 3D object onto a 3D globe, or so if the Earth is a globe, you can project a globe onto a globe. I mean, that's
3D. You
Be
can't
careful.
have 3D though, can you? Tell him, Ruhif.
I don't even get the argument.
You've got to
Arm of the
forget,
surface
forget
of the
about the
sphere.
monad, right? Get rid of it. It's not there. But always think about it.
Arma, they say that the surface of a sphere is 2D.
Yeah, that's how math works.
It's treated as 2D, but it is actually a part of a 3D shape existing in the 3D realm.
It's identifying.
2D? Wait. Sorry, Geo. Don, go ahead.
Surface treated as 2D, so you can do maths on it. But if it's curved, it means it's 3D. You're just not concentrating on it as 3D. It's usually hypothetical at this point, but the Earth might be a 3D shape.
You're not meant to say
point
that,
on a
Dawn.
sphere.
Don't
To identify a
Just say
point on a
whatever I
sphere,
want,
you
Bev.
use two
Let
coordinates.
Ruhif speak. Come on.
Yeah, to identify a unique point on a sphere, you use two coordinates. The end.
Yep.
2D.
Doesn't make it 2D though, does it?
Informationally, though, you could. I mean, this is sort of a silly argument. I mean, it's just.
It's not an argument. It's just a statement, right? Like who's making
it's
an argument about
triggering.
this? It's
Bev's triggering over 2D and 3D.
3D.
I just
He can't have both in his head. It's too
we're just
much.
wasting time with this, though. Like, well,
Yeah,
who gives a
like
shit?
Dawn said, right? 2D's a plane, isn't it, Dawn? And then if you curve it,
No,
then
no.
it's 3D.
You guys
treated
waste
as a
so much.
plane.
You
Doesn't
guys
mean
waste.
it's horizontal and flat.
Yeah, that's
Oh my-
that's what he means, Ruhif. He means 2D's a plane, obviously. Everybody knows.
No,
that.
I just told you it's not a plane. It can be treated as a plane.
What, 2D's
It could-
not a plane?
It could be
2D is a
curved.
plane, though, isn't it? Length and breadth.
Your
It's not a
definition
plane,
of
but it
plane
can be
is,
treated as
is
a
an
plane.
invisible flat surface.
It's not. No, it's not. It's not
What's
flat.
a plane?
It's just
then?
a plane.
What's a plane, Bev?
2D.
What are
Right?
the
Everybody
qualities?
knows
of it?
2D is a plane.
What are the qualities?
X
of it?
and Y.
Can it curve?
You know, like when you did maths at school, right? You've got X and Y. Just those two. That
And the line between them
depicts
curve.
the plane.
If the line between them curves, is that still a plane?
You can draw a squiggly line on a plane. Yes.
You can't answer.
Yeah, you'd need a plane to be able to draw a squiggly line on, right? And that plane, right, as you know from mathematics on the chalkboards or whatever, all of the Y's and all of the X's are perpendicular to each other. So
It depends on your mathematical.
would that be offensive to call them horizontal? Like, would it
just
be
depends on-
offensive to call the X and the Y axis horizontal and vertical?
Yeah, but it depends on your coordinate system, right? That's all.
My God, you jumped from points to axes. You don't know what you're talking about.
It's just the two straight lines, 2 dimensions. That was what I was explaining.
It's 2
Doc.
lines now, not 2 points.
On a plane, you can have as many lines as you want and they will all be within the plane. None of them leaving the plane. They would
And the
all
plane
be within
curve.
the plane.
And the plane curve around a ball.
No, planes don't curve.
Okay, there you go. That's your issue.
What?
Gauss had an issue.
Planes don't curve, you said. That's your issue.
Yeah, planes don't curve, right?
So you're imagining a massive hypothetical flat wall.
A plane, yes, a mathematical plane.
Yeah.
Yes.
And that's your issue.
Okay.
Dawn,
Give us an idea of another one.
How many coordinates does it take to, define?
Get to the center of a Tootsie Pop.
No, come on. Let him explain his plane that isn't a plane.
Well, he's not going to. That's why I'm asking him this question. How many coordinates does it take to define a sphere? The surface of a sphere. Go ahead, Dawn. Answer. You know the answer.
What's the question?
how many coordinates does it take to define the surface of a sphere?
Is it 3?
Yeah, it's 3.
It's not. It's 2.
Wait, what are we talking? Wait,
The center. It's just the radius. Just that's it. That's all you need for a circle or a sphere.
That's a circle.
Yeah,
then.
the
Sphere as
center
well.
and the radius.
That's
Yeah.
all you need.
No, you have 2 angles. Okay, you have the
No.
angle. You
No,
have
you
the
don't.
angle.
You need the
You
radius
have the
for-
radius. You have the angle of the radius, and then you have the angle moving
Do you
to
mean
the
the
right or
angle
left.
of the radius?
It's a sphere. It's not a circle.
Yeah, if it's
What?
a circle, there would be 2, but I guess if it's a sphere, you need 3.
You would need
No,
3.
you don't. You need.
Yes, you do.
No.
Wait,
No.
hold on.
Come on, guys.
Wait, can we real fast restate the question? What was it again? Just so I
Sphere's
can.
just a representation into the 3D realm, right? Of a circle. Circle's 2D. Sphere is 3D. Extra dimension. Simple.
The reason why it's 3D is because it takes 3 coordinates to define it.
No.
So
Because
then what?
it exists in reality,
where's-
like everything in reality is
what is
3D.
where's the third dimension, right? If you're only using 2.
2 dimensions is a mathematical concept.
That's
you
that's
learn
called, right. That's a
geometry.
2-dimensional object, right?
No, there's
But-
no such thing as a 2-dimensional object.
Bev, are you trying to like convince yourself that you're wrong? I don't understand.
Yeah, it's very meta.
Well, yeah, the 2D, there's no third dimension. So, I mean, how can it exist? You need 3 dimensions to exist in reality. So, a circle being 2D is the concept of a circle.
We're talking about a sphere.
Yeah, you add the other dimension, it's 3D.
There you go. Okay, so why are you arguing?
I wasn't aware that I was arguing. We were talking about a sphere being 3D, but Ruhif wants it to be 2D, and Dawn as well. He wants a plane to be able to wrap around a ball.
Hyperbolic plane. I looked it up now.
Talk about the surface, though. I mean,
It's not a plane, is it?
Hyperbolic plane.
No,
The
but
surface of a sphere is not a plane.
that's not
Hyperbolic
like what surface
plane.
is. Hey, look up the definition of surface, man. All right.
Bev,
Like,
you're
wait,
not playing the game properly.
Is that your best
I'm just
comeback?
trying to
Look
tell
up the
you.
definition of surface.
Yeah, because I mean, like, we're arguing like a non-argument.
arguing.
That This is so silly. We're wasting time with like
It's not
trivial
wasting time.
shit.
What is the surface?
I
of
don't
a
even
sphere? Is
know.
it-
I just jumped in here. I don't even know what you guys are talking about, to be honest.
Math-
But-
You do. You're on point. Arma, the surface of a sphere, 3D or 2D?
Surfaces by definition are 2-dimensional.
Of a
what it's-
sphere.
Yeah, it's 2-dimensional. It's a
Not
surface. It's a surface of
always.
a.
Not if they're
Yeah.
bumpy and stuff.
Yeah, now if you want to say colloquially, like, oh, the
Yeah.
surface of something, this is bumpy, whatever, right? That's a bumpy surface, right? Colloquially speaking, then you can argue that there is 3 dimensions because it's bumpy, therefore there's actual like height to that and whatnot. But we're not talking about that. We're talking about like the mathematical, the surface of an object is
Yeah,
2-dimensional.
we're talking about literally every
listened to
object
the-
that you see that has a surface that exists in 3-dimensional space. That surface is defined with 3 coordinates, meaning
Yeah.
it exists. It's by definition in a 3-dimensional aspect.
Yes.
Because it has a curve. If it didn't have a curve, then it would be flat, and it would be 2. You could define it with 2.
Okay, but the surface is what?
Which is what Bev tries to do with Earth, and that's why it doesn't work.
Just reality.
Yeah.
That's
I
all.
mean-
That's all we do.
I mean, like Archimedes was totally full of shit.
If I look it up and he's a glober, what would you say then?
I would say he would put the sphere into water and it would
Full of
displace
some
it.
shit.
The surface of the sphere would displace water.
If he's a glober, would you
No,
say?
it's the
only full of
volume of
some
a sphere that displaces the. What do you mean the surface?
Oh, the surface doesn't displace the water?
Isn't it It's the volume because I mean the amount of volume the water the sphere takes up is how much water that
Volume
This is
doesn't
the
have a
exact
surface
point.
then.
Show me a surface that doesn't have a volume, right? And,
Exactly.
And that and then
that's not the argument.
No.
Yeah, it is.
Have
If,
you
if it
seen
does
it in
have
the
a
chat?
volume, then it just has an area, right? It's flat, meaning like if you know, if you filled in the space underneath the curvature of that curvy surface, right, surface, then you could say it had a volume. If you just look at a flat 2D thing, then you say it just has an area. Or that curvy surface, you can define it and say this is the surface area, right? The area of the surface. But that surface is still taking place in 3-dimensional space.
Okay.
Yeah, there you go.
Okay.
Check that out. If a surface is fully submerged into a liquid, then the volume of the displaced liquid will be equivalent to the volume contained by the submerged surface.
Yeah. I wasn't disagreeing. I was literally saying that.
So what was the argument in the first place, though?
We call that one the 2D, 3D displacement method.
You guys are whack, seriously.
The very
good,
early
though, isn't it?
argument.
Wait a minute, Arma. That is totally unfair.
This is a waste of time.
You were agreeing with them that.
I agree, it is a waste of time.
Okay, whatever.
I think the original argument was it was claimed to measure
Has to be 3D, right?
degree difference from looking at a plumb line in the distance. Globe was claimed to see diversion, proving globe, and Bev doesn't believe it.
Okay.
Really?
Why don't you believe it, Bev?
It was a bit of a misrepresentation, wasn't it? Did you just build a straw man there, Don?
Oh.
Do you believe that they can measure diversion from plumb at a distance?
Well, he might as well try to beat it down. He's already built it, so he might as well
Yeah.
take a couple swings at it.
No, Don, I don't believe. Like Ruhif says,
That's what I
you
claimed.
you can measure it because it's always away from you, apparently.
That's what I claimed just now about you.
You can't make a deviation on a vertical plane of a vertical within the plane.
Wow, you're actually saying it's impossible, not that it can't be measured, it's impossible.
Wait, Don, you can even
So
be
you are a
90
flat earther.
degrees from that vertical, and you cannot measure it. So, I mean, go figure that.
You
I
said
do
it was
think,
a straw
I do
man.
think
You
that
said
there is a vertical plane,
misrepresentation,
Don.
and then you agreed.
I do think there's a vertical plane, right? Does that bring your bigotry into effect? Does that,
Sorry, I'm still stuck on the idea that you said I was misrepresenting you, and then you agreed with my claim.
You haven't made a claim, Don. It's
You
all
don't
over the
believe
place.
you
Everybody
don't
knows.
believe they can measure diversion of plumb at a distance.
Yes, you cannot measure
So you-
the diversion of
agree.
plumb ever
You agree with my
anywhere.
claim about
There's
you.
nobody that's claimed that they can, except a couple of lying people on the internet. And
So
you
you
watch
do
their
agree.
videos.
You do agree with
The
my
shadow
claim.
giants dancing on the walls that you keep
They've
spouting out, Don.
Okay.
Yeah, but they've watched the
good.
videos and can't explain the videos that they've watched.
I don't watch that shit.
Oh, yeah, of course.
I'm updating Amada because you don't talk sense, so I'm telling him.
You gave up
your
perpendicular
emotion.
for
Wait, what
vertical
about me,
and
man?
horizontal,
I'm
Don.
telling him your arguments for you.
Oh, okay.
Does armor also give up perpendiculars for vertical and horizontal?
We don't know what that means, Bev, because you're using too many words, and we don't trust
Too
your
many
real
words.
meanings of those words.
Armor, can you have verticals that are parallel on a vertical plane in reality?
A vertical plane.
Yes.
Verticals on a vertical plane. So wouldn't the verticals on the vertical plane, because the plane would be oriented vertically, so
Yep.
are you
It's a
saying that
vertical plane? Yeah.
So would the verticals then be like technically horizontal at that point, or like,
No.
am I picturing this correctly?
No. Two verticals on a vertical plane in your mind. There's a one horizontal line, right?
I'm not sure I'm picturing this correctly.
Are the verticals perpendicular to the horizontal?
And you draw lines in a straight direction along the plane.
Driver.
Parallel. That's
Well, he's saying vertical planes. I'm thinking you're taking a plane, right? Like imagine you go to Blender, you take out like a fucking square.
Yeah, like
and
a
then you-
like a
and then you tilt
whiteboard
it.
on a wall, right? That's it. Imagine
yeah,
that.
yeah.
Imagine a whiteboard on the school wall, right?
Okay.
And now you're going to draw two verticals on that
Oh, okay, yeah,
vertical
yeah.
plane.
Okay,
and
fair
then you're
enough,
going
yeah.
to draw one horizontal perpendicular to the vertical plane.
Right. Okay. Now I got it.
Right.
Now I picture it.
Is the relationship between those verticals and that horizontal, is that perpendicular?
The verticals in that, yeah, would be perpendicular to the horizontal.
Jolly good. So they would be parallel verticals then.
In that, yeah. In that little example, yep.
Brilliant. You know that Beddy said he made an argument that there are no parallel verticals. But you've just said that there were definitely two then.
He probably
That's
meant on
because if
Earth
it's not
in
a
reality.
curved
He probably
plane,
didn't mean on your hypothetical vertical plane. He probably meant in reality
over.
because Earth's a globe.
Correct.
Okay, right. Well, let's start again then, Armour. You've got two verticals on a vertical plane in reality, like a whiteboard on a wall.
Yep.
Right now,
Above Earth.
Can you
it is a
draw
globe.
a horizontal line on that vertical plane? One.
Yeah, and you could draw on that whiteboard. Yeah, you could draw a horizontal, which is the vertical plane in this, hypothetical. Yeah, you could draw a horizontal line on it.
One line on a vertical plane. Imagined. You can have a vertical plane. Imagine this. We're in the mathematical realm now of perfection. So we've got a perfect two-dimensional plane vertically, and it's represented as a whiteboard.
Okay.
Right. What we're going to do is we're going to get two verticals, plumb lines, and place them and put them on that vertical plane.
Yep.
And then we're going to get one horizontal line and place it also, boom, on that plane. Now, can those plumb lines, verticals, be perpendicular to the horizontal?
God, he agreed to this. Why are you asking that all again?
Yeah, dude.
Yeah, sure.
Kind of like talk a lot.
Why did you ask the same question in long form twice?
Yeah, that was essentially the same thing, actually. Now that
Because he's asking Arma.
Yeah.
Because he's obsessed.
No, it's very accurate to the mind. Armour has verticals being parallel, at least in his mind, in the mathematical realm.
To an imaginary vertical plane. That doesn't mean Earth's. That doesn't mean all plumbs are going to be parallel all the way around Earth.
It means when he imagines it in the perfect, he goes to mathematics. He doesn't get clouded by a model, right?
How are you going to apply
now
that?
let's apply it in reality with actual plumb bobs and a level. Right, so you've got two plumb bobs and a level.
Okay.
Can those plumb bobs be both perpendicular to the level straight line?
If depending on the surface of of what we're on.
No, this is in the air, right? The plumb bobs are in the air, and the level is also in the air. Nothing to do with what you stood on.
Well, yeah,
so you're applying it, but it's nothing to do with what we're stood on now.
But hold on,
How is that applying it?
Correct me if I'm wrong. Don't plumb bobs? I mean, I could be wrong because I actually don't know too much about them. But don't you need to like drop them or something, or they need gravity to, don't you have to like hang or some shit?
They're vertical. They're a representation of vertical in reality that we use.
But don't you hang them or some shit? Like, don't they have to like dangle or whatever?
Yes.
Yeah. So
but
I mean,
consider them just hanging in the air. You say.
Yeah.
We're
So
just
if
talking about the lines.
Yeah. So I'll grant you that if down is universal, then sure. In this hypothetical, if down is universal, down is always down. Or at the very least, the direction of down, or the direction of the way that how things fall, whatever. If that's always the same, then the plumb bombs could they will be perpendicular to the the level or whatever it is. But we don't really know. Like,
what about if we say horizontal then, right? Forget about level. Let's say horizontal. Is there a possibility that you can place a horizontal plane within these two plumb bobs where they're perpendicular to the horizontal?
It's possible, once again, if we assume that there's a universal, like because we're dealing with plumb bobs. If there's like a universal down or direction, things falling down, whatever, then sure. But it really depends on.
Yes, on a flat Earth, Bev, that's correct. But
yeah, on a flat Earth,
you'd have to do it for real.
Not just in reality. I was just saying, what do people imagine? That's all we're doing.
Right? Yeah, but I mean,
we're saying,
but when you imagine,
because Armour's got a vivid imagination as well as you.
Globers.
Yeah, but
we're globers, so we know plumbs divert as it goes round.
Okay, so can you have these plumbs being vertical, perpendicular to a horizontal?
I think plumbs at a certain distance divert from each other, meaning one of them won't be plumb to the original horizontal; it will be plumb to a new horizontal round the globe.
Mm-hmm.
Yeah, Donegal.
Dornagon globe, we call it.
Yeah.
A sphere, like a ball. Very simple shape. Not something I made up.
Yeah.
An actual shape.
Do you have any way to substantiate it other than just an assertion?
Yeah, the drop from horizontal that people measure, obstruction, sunsets.
What do you
So
call
we're
the shorter distance then?
We're gonna end up back at Jesse Kozlowski.
No,
Yeah,
this is
we're
right.
gonna
We're
end up back
in
at
right
you
in the
guys
fundamentals, Don.
not knowing how to measure.
What do you
measure
call the shorter distance than the horizontal? What do you call it? Let's give it a
surface
name.
of Earth, level.
The curved surface is shorter than a straight line. That's Bob territory. What? Be careful.
Well, the straight line goes through Earth, which you can't walk, can you?
That's a good
But
point.
the horizontal is the shortest distance, right?
No,
Everybody knows that.
on the surface of a sphere,
You've
no.
got something shorter than
Just
a
no.
horizontal.
Yeah, the Great Circle route.
A curve, yeah, you have. You've gone full.
I'm afraid if you're on the surface of a sphere, the curve is the shortest route on the surface, unless you tunnel through the ground, which takes time.
Shorter than a horizontal. That sounds mental, that Don.
That's your issue. You need everything in reality not to be curved. That's your issue.
I just can't see how a curve can be a shorter distance than a
You're
straight line.
denying the surface of real shapes that you've held in your hand before. That's your issue.
I'm just not deluded, I guess. But I mean, hey, I don't know. I don't know what sort of community we're in around here, Don.
You're obsessed with geometry and you stopped at 2D.
It's 3D. Have I said that?
You
all
forgot.
along, Don.
You ignored the full
reality is
geometry study of
3D.
3D.
Yes.
Yeah, you ignored that. You ignored the geometry.
Book 11 is where we started, Dawn. Book 11.
If you're going to try and apply 2D Euclidean geometry to the globe, you're going to be wrong every single time.
Okay, there's the statement, right? So what do you apply to reality?
All of geometry, all of math, all of logic, all of science.
Oh,
not
please
just
say,
Euclidean.
You should just say
In
spherical
fact, you can
geometry.
throw Euclidean right in the bin and get on with the rest of the study.
You can't use logic to refute Euclidean geometry, obviously, because I don't know what you're doing.
I have already. I've
I
given
know
you the
you
logic.
have, obviously,
If we're
Don.
standing on the surface of a ball, Euclidean geometry breaks down. That's my logic.
The ball is Euclidean. And you're standing on it, Dawn.
You can't use his 2D plane principles and make them work on the surface of a sphere in reality.
But you are.
No.
They do. Everybody
No.
else does. Like the
No.
people that believe in a globe, they're hyperbolic and spherical, which is 2D.
Hyperbolic planes.
Hyperbolic and spherical that's 2D geometry.
Some of it's treated as 2D, but you have to use the 3D to know.
It never makes it into 3D, Dawn. The only geometry that ever makes it into 3D reality is Euclidean.
Yeah, book 11.
One day you'll manage to study how balls work, but you haven't got there yet.
Right, yeah.
Logically, plumb bobs diverge from the original horizontal. You're going to have to choke on that.
How? Come on. Please derive that logic.
Because Earth's a globe, and plumb is pointing towards the center.
The monad.
The monad. No,
So you start the whole thing off with a begging the question and an affirming the consequent.
We have a
Did
hypothesis.
this like 3 hours ago with Jesse. It was
Yeah.
like, if the Earth's a globe.
Yeah. It's not an assumption. It's based on all the other knowledge that bears ignoring. So with all of that knowledge, if Earth's a globe, his geometrical proofs fall on their face and can't prove what Earth is.
If then, that was a good one. Go on.
Yeah, no. Say it in a logical format. If then.
I've said it pretty clearly twice.
Oh, come on, Dawn. Play the game.
It's not a game. It's you being dishonest and me trying my best to correct you.
I'll
It's not a
try
game.
to do some
You
logic.
can
Give us
call
a
it a
good
game.
argument.
Just put it into a logical syllogism.
Yeah.
Nobody wins, so it's not a game.
All right. Well, if you don't know how to, we could go through it. We could do it.
Can I start off with one? If plumb lines are vertical, and if vertical is perpendicular to horizontal, then all perpendiculars to the horizontal plane will be vertical.
Okay, that's fine and all, but you know,
Go on, refute it. Come on.
Well, okay, well, because you're assuming that these verticals are all the same, like vertical, like
Are they
sure.
perpendicular to horizontal?
In hypothetical math, of course it is, Bev. But so what?
But Bev, hold on. You're assuming that all the verticals are, they're all perpendicular to the same or horizontal, whatever. But I know you get maybe you're gonna make fun of this, whatever. But like, you can
No,
have
no.
multiple
Actually, as per
verticals,
all
multiple
definitions,
horizontals.
as per all practical definitions, that's what it is. I mean,
How would you do
he's not claiming that all horizontals are parallel. You're claiming that they aren't.
Okay, but it's still just a name, though. Like, we got verticals, whatever. I mean, it's still just a name. Like, a name doesn't like somehow magically make the
Yeah,
thing
that
like
has practical
true.
use as per the
Elijah.
definition.
Elijah,
Like
do you
I
get?
said, but you have one definition that differs from that, and that's not practical. It's actually begging the question. But
You
within
get
the definition itself is a contradiction.
All
But I
I'm,
mean, you can go ahead and shoot it out there
well, I mean,
if you like,
it's just
or
silly.
just address what he said. But you
It's
can't tell him that he's assuming. He's not assuming. You are.
it's just a silly argument to be like, okay, well, because it's named that. Like, okay, the atom was named the atom because we thought originally that it was the smallest thing. It's
That's
not the
not an
smallest thing. But
argument.
the point I'm trying to get at is that just because it's called vertical doesn't mean
That's
it's
not
truly
even a
vertical. And it's,
definition.
Well, wait a minute, though. Wait a minute, Arma. Like, within mathematics, I mean, are horizontals parallel?
Are horizontals parallel? I mean, yeah. I mean, if you're assuming the same horizontal, sure. But
Wait a minute.
If it's the same one,
I mean, are verticals parallel?
if you're assuming the same like orientation, whatever, same vertical, then yeah, sure. I mean,
how would
it
you
is.
do
You
math
guys are
if
asking
that?
questions,
would
but
you?
it doesn't relate to reality. You're just saying in
No,
math
wait a
does
minute.
this work, and we're saying yes in math. But how does that relate to Earth?
Because that framework works in reality.
Well, but Bev isn't claiming that. Bev doesn't have the balls to claim that. It's only you claiming that.
No, Pythagoras did.
No.
Yeah, he
Pythagoras was a glober, bruv.
It's also done in
Pythagoras-
planar surveying all the time.
I mean,
Pythagorean theorem works in reality.
That was a glober. He's a glober.
But is this? Come on, is this what you guys really want to argue about? Like definitions? Like it's silly. Like
That's all Bev wants to argue about.
How
is it
definitions
silly
in math.
to argue
How would
about
Pythagoras be a glober?
Please, can you stop saying that I want to argue about stuff? It's not me that's arguing. I'm just stating facts about
What's that
horizontal
mean,
and
Paul, then?
vertical and what
Why are
happens.
you saying math facts that don't relate to reality? Why?
What?
Well, Don, hold on, Don. What did he say? How does it relate to planar surveying, which does relate to reality? Horizontals, verticals,
the
it
question is,
precisely
why are
relates
you
to reality.
assuming that? Why is he saying that Bev is assuming something? No, he's not. Like he's only saying it's an assumption because his assumption that all verticals aren't parallel. That's a fucking flip of the burden of proof.
Elijah,
The
he's
truth
made it.
is, no,
He's made it
actually,
out of a meme.
as we use it, when you need to have a vertical, it's referenced off of horizontal. All he's asking Dawn to do is address that, or the other guy to address that, and they won't. They're like, oh, now we're talking about definition. Oh, now you're assuming. He hasn't assumed anything.
Slow down. He is assuming. He's asserting.
Stop talking for me. Address the issue.
I'm talking to Elijah. Shush. He's asserting certain math proofs and subtly suggesting that Earth fits that.
No, I've never mentioned it. Like, that's you talking about that, Dawn. You can't get it out of your head. Don't assume that that's what I'm talking about because just because you're obsessed with something.
Again. Why are you asserting math proofs that don't fit reality?
Because all of the maths proofs are from reality. The people that made the mathematical proofs were in reality when they made it. Mathematics is a representation of reality. Just maybe not your reality, Don. Maybe you're obsessed with something.
We agree in your hypothetical. The verticals and the horizontals are parallel, but that's just a hypothetical.
Well, hold on. Is that what is the case in planar surveying?
In planar surveying, I think they're just measuring elevation change for topography. So they're not
Yes.
concerned with if Earth's a ball or not.
No, they're
'Cause
not.
They already know.
Nobody else cares about it, Don. Just you
I'm afraid
and
they
your
do. They already know it's a
group of
ball.
people that are obsessed with it.
They know it's a ball.
They just know it's reality. They don't care. The real globe, Dawn, that's where everybody lives. And everybody has level being horizontal in reality.
Sorry, I meant Geo. You and Buster
But
Geo
but,
are trying to
but what
argue
is
this could fit
that's
reality.
the shit I'm talking
There
about.
isn't.
I'm sorry, that's the shit I'm talking about because what kind that response right there, Don. Um, what do you mean by they just deal with elevation change as it pertains to topography? What
Saying
because
planar
because
surveyors.
when we talk about when we talk about level and we talk about elevation change, there's only one way to do that, unless you think on top of that there is some sort of 8 inches per mile squared drop. Now,
Yes.
if you're going to say that level is the change in topography and not that at the same time, that's what we call it.
What I was
That's what
saying
we
is
call a contradiction.
planar surveyors are not interested in
That's how you
measuring
prove the
Earth.
dogmatic globe, that, you know.
They're not
What
interested in
I
measuring
just
Earth to be a globe.
I
Oh
just
my
told you that what
God.
you're trying to
Why are you
infer is
asking me
that
and then talking
a
over me? What's wrong
contradiction.
with
Yeah,
you?
come on, guys. We gotta.
I mean, because he's not really responding, Gio, to what I just said. Yeah, basically what
Oh, I
he just
tried,
said
but
that I
you and
just
Bev both
responded
spoke
to
over
that
me,
he's
didn't
about
you?
to repeat is that is a
Elijah's.
contradiction in terms to say that they're going to talk about topography, but it has nothing to do with the elevation change as far as a sphere is concerned. That's a
Exactly.
contradiction in
Oh
terms.
my God, you're confused.
That's why that's how we're going to prove the dogmatic globe, right, Elijah? Just like that.
You're not going to prove the dogmatic globe.
Absolutely,
It's already proved.
yes.
Already
Elijah's just
proved.
going to do it now, right? Because what you're going to do is you have to accept that, obfuscate, and pretend Elijah just didn't hand you a contradiction. You can't see the contradiction,
Lost
therefore,
in the weeds. I'm still
dogmatic
waiting.
globe proof.
I'm still waiting to respond.
You're going to hand wave away a contradiction. Everybody can hear it. Everybody can see it. Everybody knows it goes on. But
what are you talking about?
Dogmatic globe proof, Dawn.
What is that?
It's what you're going to do right now.
All I'm going to do is tell Elijah that I believe geodetic planar surveyors are not measuring to check if Earth's curving. They're just measuring the ground changes up and down, sea level, get the maps correct with topology, because they already know Earth's a globe through using logic and trust.
Logic and trust.
Yeah, the best ways to know things.
Do you think it's more of assumption than logic?
No.
Well, it can't be
More
logic if
assumption than
it's a
trust.
contradiction in there.
There's no
That's
contradiction.
that's obviously a basic first. The logic is not to have any contradictions. You can't talk about elevation change minus 8 inches per mile squared because that's actually assumed because they're not really looking for earth curve. That's ridiculous.
No one calls that
Dogmatic globe
elevation
proof.
change. No one calls it elevation change. That's the curve of the Earth.
Dogmatic globe proof.
Dawn, are you serious? Like, can't you see long distances?
What do you mean?
Well, we
Well,
can
curve of
see
the earth
long
is
distances.
elevation change. That's why it's a
No, it isn't,
contradiction.
Elijah. If you get that
Yeah,
wrong,
it is.
you'll always be wrong. You'll just
Yeah,
be wrong.
mountains. You can see the curve of a mountain, right? That's an elevation change. That's a curve that you can
It's not the
see
surface of
that
Earth,
is an elevation change. That is the surface. Yes.
No, it's not sea level surface curve. What we're talking about.
Well, I don't know what you're talking about. You're talking about something
Yeah,
you
pretend you
can't
don't
see.
understand the globe.
Yeah, you're
That'll
talking
make
about
sense.
adding
but how-
angles to a straight line, Dawn.
No, I'm talking about a hypothetical planet in space curving because it's a
You're
ball.
creating a hypothetical? What?
Only the finest logic for Dawn.
It wouldn't be elevation change because sea level is level all the way around the curve. It'd still be the same.
This guy gets it. Honest enough.
It'd be better to say the divergence from the
No,
horizontal perpendicular line.
I'm sorry. You can't. Well, you're saying this guy gets it. I get what he's saying. What he's saying is a contradiction contradiction in the term level then.
No, it isn't.
I don't have a contradiction in the term level when I'm just saying I'm measuring an elevation angle change.
Yes, you
But
do.
you're begging the question. You're saying that, well, I can measure a change in elevation that has nothing to do with the drop over
No.
distance, which would be
Wait.
an elevation change. I don't
He isn't.
understand
He's not
why.
begging the
But
question. He's saying that's what globers mean when they say it.
I know, but there's no practical way to prove that you'll be measuring elevation change minus 8 inches per mile squared or drop over
Yes,
distance.
there is.
Are
People
you
have
guys?
done it for thousands of years.
Are we happy
Yeah,
like wasting time here?
that's sad. That's super sad.
Nigel doesn't
I'm
get
not
it.
gonna argue this
That's
all
what's
day. It's
he
Monday
doesn't get
morning.
any of it.
I mean, don't we want to make progress here? I feel like, come on, is this what we want to do? We want to
Let's
waste time?
move on.
Thank you.
We were talking about vertical planes. Let's get back on that.
You were talking about that imaginary
Yeah, it's
walls.
the
in
vertical
space.
plane that you measure a vertical angle in.
You guys are talking in circles. Don already said that there's a measurement that's observed on the horizontal perpendicular line that you're theoretically talking about. There's a measurement. There's a divergence between the Earth and that perpendicular line.
Yeah.
He's already said that. You're saying that there's not, and I agree that I believe that there's not.
You
But
don't
we have to
use Pythagoras
substantiate
with
that.
a right
We have
angle
to
in the far side of it, do you? When you
Now,
have
Don has to prove it, though. Don has to prove his point that, in
Don
fact,
can't
there
prove
is a
anything.
divergence from that perpendicular line with the original plumb bob, right? You put a square to that plumb bob, and you get that horizontal line that goes out to infinity. That horizontal line that's, calibrated to that original perpendicular plumb bob. According to us, there should be no divergence between the Earth and that horizontal line. And I agree with you. I haven't seen that. I haven't measured. I haven't seen that. But they're saying that there is a divergence.
No,
and
we've gone a bit simpler than
squared.
that. We've gone a bit simpler than that. Since the recent events, vertical planes are now not possible, if you didn't know.
Who said that?
The true geometric vertical plane.
How did you conclude that?
Well, because verticals can't be parallel.
No.
Who claimed
on a
that?
globe? People say on a globe. They don't say never.
Well, in reality?
In reality, stretched round a ball, that can't work.
Yeah. So in reality, either verticals are parallel or verticals cannot be parallel.
Why are you lying? I'm telling you,
How
it's
many
both.
how many parallel
on the surface of a
verticals
ball,
can you
it
have?
can't work. On flat things, it does work.
Okay. So in reality, what happens in reality?
I think Earth's a sphere in reality. So I think your imaginary wall sticks out into space.
So verticals cannot be parallel in your reality.
They are parallel, but not on the surface of a globe all the way around.
Right. So are you on the surface of a globe?
Yes.
Okay. So are verticals parallel?
When they're close to each other, we can call them parallel.
Are they, though? Are you fooling yourself?
I'm telling you, they're partly parallel.
You just want to fit in with everybody else by saying
parallel
they are.
means...
Are you being true to yourself?
Parallel doesn't mean exactly because of Beth's math.
It does.
It
Parallel,
means
that's
they're nearly
exactly
parallel.
what parallel means.
No, sorry.
It means that no triangle will ever be formed with 3 lines.
Whoa.
I'm afraid that's only hypothetical, Bev.
Did he just say parallel doesn't mean parallel?
Well, I mean, look, okay. Hey, how about this, right? Because I will say this, right? Yeah, technically speaking, parallel, is perfect, but there's no such thing as perfect. You can't have perfect things in real life.
Mathematics. Parallel is a mathematical term, though, right?
Yeah, but I mean, like, okay.
But
the point is, all right. I mean,
either
you're not
parallel or not parallel. That's the logic laws, right? Have you heard of
circles
the
don't
basics?
exist because circles have to be perfect. Spheres don't exist because spheres aren't perfect.
Only in the mathematical realm. Yes.
Yeah. So
that's
then,
what we're dealing with. Perfection.
Okay. So then that means even parallel doesn't actually exist in real life because to get actual parallel, that's literally impossible. You would need to be like literally.
You're talking mathematically. When you use the words, you are talking mathematically, right?
No.
Yes, of course you are.
No, you are.
Yes.
Other people aren't.
But why would you? Why would you say that you can't get parallel vertical? Why would you say that?
Nothing's perfect, and he's only talking about math
No,
proofs.
I didn't ask you. Arma.
Wait, who? Wait, me? About what?
Why can't you get verticals to be parallel?
Did I say that?
Yes, you just did. And I'm
Just
just
like right
asking
now,
why.
or because I was saying that like
You just did, so I'm asking why.
no, what I just said was that in terms of
Yo,
like
wait, am I smoking? Did he
maybe you
not
are
just
smoking. Let me
say?
say what I fucking said, all right? And don't tell me what I said, okay? What I
Well, hold on,
said.
no,
No,
don't
no,
do
no. Let
that.
me say what I said, all
Let's
right?
get a third party. Let's get a third party. Did he? Not you. I'm not asking you now because I know you're willing to lie. Someone else who isn't me or Dawn or Arma. Did he not just say
Yes.
that verticals aren't parallel?
You'd have to be God. He said you had to be God to
No,
make
I
it.
said you'd have to be God if you want things to actually be parallel, like to truly be
Exactly.
parallel.
So let's not be semantical.
Yeah, but that's what I'm saying. That's why it's fine enough if something is close enough to parallel. I mean, I guess you could argue.
You're double speaking, bro. Like,
Don't you feel
just
like
stop.
you're in a cult the way you're talking right now? Like, it's
No.
coming off real cultish.
No.
You're a member of the Bavarians, Elijah. Did that happen? You did the initiation and all that.
So would
Do not
you
believe
would
in
you
90
say
degrees?
then if vertical and horizontal were perpendicular, forming to the mathematical understanding of that, that could be God that did that? Is that what you're saying?
No, it's just no. What I was saying is, if you want to truly get something parallel in reality, right, you would have to have like infinite precision because that's what you would need. You know what I'm saying?
Perpendicularity, right?
Otherwise, yeah. Okay, I'm saying if you want true parallel, if you want true parallel, then you have to be God. But the thing is, we can't get that. So let me. Can I fucking finish, man? Seriously, hold on. So because what you're about to say.
If you have a perfect perpendicular twice, the only reason it wouldn't be parallel is if you have a belief that you're on a sphere.
No.
Or a disbelief in God for you to be able to make it possible, right?
A tiny
Because
bit
he
true,
doesn't
okay.
have it even being possible without a God.
Armada, shall we just give them that we think Earth's a globe, so nothing's parallel?
I mean, yeah. I mean that's.
But no verticals are parallel because Earth's a globe, and they need to just choke on that.
Yeah, obviously it's us, isn't it, Don?
Yeah.
Yeah.
Your math's broken down. We've denied you. No, they're not parallel. Fuck you.
I'm not too sure why you're allowed around here, Don. You're obviously going to infect people's
I feel the
minds
same
with
about
some
you.
crazy shit.
I feel the same about you, totally.
Mm-hmm. You've got nothing, no argument, no.
What's
nothing.
your argument? That math should apply to reality, even though you can't make it apply?
If all horizontals are parallel
so your
to the
argument
plane of
is
the
an if.
horizon,
Hypothetical
then
if bullshit.
all horizontals will be parallel to each other. Yes.
Your best argument is
there's an
hypothetical
argument.
if.
Yeah, if then.
Why do we allow this
some,
round here,
Some
Gio?
of the best arguments, positive modus ponens.
Buster and Gio and Elijah are here to make real arguments, and you're here to make ifs.
Well, it kind of seems like you're projecting, Don, because you just did a whole begging the question. You just said that everyone needs to just accept it's a globe.
I didn't.
Meanwhile,
I did
Bev is
not.
actually putting forth a logical syllogism and showing how that relates in reality directly.
I didn't say that. I said they need to choke on the fact that we think it's a globe. I don't think they should just believe it's a globe.
It's just
That's what you
reality.
It may have sounded like that. I was insulted.
Well, it sounded like that's just what you said.
No, I didn't say you need to just cope that it's a globe. I'm saying you need to cope that our answer is it's a globe, so no verticals on the globe are parallel.
All right, well then do you have a logical syllogism to back that up, and then you have a way to validate that in reality?
I don't care for logical syllogisms.
Mm-hmm.
And you don't care to link it to reality, so you're just you're in a hypothetical idea.
Yeah, I'm linking it to reality, but I'm not proving it is reality. I'm linking it to reality to say all spheres work like that.
They don't. Don't. That
Do you
doesn't
think
happen on balls. Verticals do not go to the center of every ball.
You think all
not in
verticals are
reality,
parallel?
Don. You were the
think
one that just
verticals are
said
parallel?
all spheres work like that. All spheres don't
think-
work like that.
What do you mean they don't all work like that? I
Do you
mean,
think
they're-
verticals on a sphere can be parallel?
No.
In reality, Dawn,
Yes. On real balls in reality,
you
can
can't.
verticals be
Can
parallel?
you? Well, you can slice a ball vertically, can't you?
You know what I mean by vertical? An imaginary plumb on the ball's surface.
Yeah, this is what I'm talking. This is why are
Can
we
that
doing
be?
this?
Can that be parallel with another one?
Yeah, because see, the communication breaks
Plum.
down only because the communication breaks down only because the way you're defining. Well, just saying
Want
that
me
a
to ask
plumb
you?
bob on a sphere. Well,
Do
do
you
you
think
want me
you
to
can
just?
get a plum to fucking point towards the center of a ball?
Shall we think of matchsticks with blue tack to a ball instead? Can they be parallel
No,
with
we're
each
talking
other?
about plumb lines. In reality,
we
bring
use
a
it. No,
ball
no, no, no,
near
no,
a
no, no,
plumb
no.
line. Does it start pointing at the center of it?
No, we're not using plumb lines in reality. We're
No, you're
thinking about
using your
what a
monad,
ball would
right?
be like in reality with
A
matchsticks
ball,
on it.
yes.
Now, vertical matchstick. So you've made one. Can you make another matchstick on that ball surface be parallel with the first one?
Perpendicular to the horizontal that the first
horizontal.
matchstick makes.
Yeah.
Right, so horizontal and vertical are perpendicular. We'll go with those rules. So we've
Can
got
you
one
pick another
vertical matchstick on a ball, like it. I don't know why you want to bring a ball, right? And then we make a horizontal plane.
Yeah.
Okay. Now we travel along that horizontal plane and we make another perpendicular.
No, I'm saying you travel
Horizontal
along
and vertical are perpendicular.
I'm saying after you put the first matchstick on, you travel around the surface of the ball.
No,
and put another,
you've
put
made a
another
horizontal
matchstick.
plane.
No, he was saying travel on the plane and then drop another plumb line. It's not going to go to the center of the sphere.
Why is Bev misrepresenting my challenge to him while
Because
taking
that doesn't happen to balls in reality.
Geo, let me
You
ask
can't
you.
put a horizontal plane on a ball and then imagine that the plumb bob that you're going to make will go to the center of the ball.
Let me ask you, Geo.
Don, he's linking the logical syllogism to. He's trying to apply it now to your globe model and showing how that doesn't work.
He's
But you haven't refuted the logical syllogism yet, and you're also asserting the ball.
No, I'm asking a challenge, Geo, about hypothetical balls with matchsticks on, and he's ignoring it.
You're not going to walk on the side of the ball, are you, Dawn?
I think you'll agree with me, Geo, on it. The second matchstick sticking up vertical from the ball surface cannot be parallel with the first one, can it?
Can you stand on the ball, right? In reality, let's make a really big ball where you stood on top of it with a clown suit, maybe a nose and big fancy boots.
Ignored my point, and he's talking about
just
clowns.
walk around the ball for us and show us exactly with holding a plumb bob. You tell us how it will work.
So he's on a hypothetical ball in a clown suit with fake plumb bobs. Well,
no, with a real plumb bob, like an actual real plumb bob.
Totally up in the wind bullshit. I'm trying to get him to admit that ball surfaces can't have parallel verticals. So if Earth was one, it wouldn't have them.
Well, then make a logical syllogism, and then you have to validate it in reality.
But I thought instead of logical syllogisms, I could talk him through imagining this ball, and that might be
walking on
less
a ball.
Nerdy.
But at what point is the horizontal plumb line not parallel to the Earth?
It's not a horizontal.
How far out?
Plumb lines are vertical.
There's no parallel to a ball.
Yeah, but that's that's just begging the question, man. Like, why you don't have any way to prove that?
Can I ask you, Elijah, the same challenge? See if you agree with me. If I put a matchstick vertical on a ball, and then I put another one 2 inches around the ball surface, and I decide that one's vertical too, they won't be parallel.
Yes. In your reification, not even in your example. Hey, look, listen. If you're to take matchsticks and place them around the ball, the verticals would not be parallel. But the problem with that is when you're dealing with horizontals, when you're dealing with horizontals and parallels, though, in reality, what does that have to do with the ball? That's the question.
You do agree with me, though, that the two matchsticks can't be parallel because they're sticking out different directions of vertical from a ball.
If you stick them onto a basketball, I just heard. Yeah, did you not hear what I said? If you stick them onto a bat, if you take matchsticks and you glue them onto a ball, then you don't have anything that's parallel and that are. I mean, there's no what parallel verticals. Vertical to what?
That's what They're all going to be different, but they're all called vertical, but they're all different, not
Yeah.
parallel, right? So that would be the same for globe if Earth is a globe.
Yeah, look what's so hard about
Exactly, but that's just begging the question.
Yeah,
But
we agree on that.
Bev can't admit ball
Well, it's
surfaces
not.
act like that.
Yeah, but it's
Balls
trying to
don't
say-
affect
no.
verticals
You're
in
just
my
asserting.
mind.
You're just
Don.
asserting that
There
that's
you
the
go.
case. You first you tried to argue with him by saying that verticals aren't parallel when he's saying no. Vertical is perpendicular to horizontal, and that's all he said to you.
That's not parallel on the ball, is it?
No, but it wouldn't
Did
be.
you
But
just hear what Bev
a
said?
ball
Bev
have
said-
to do with what does a ball have to do with what Bev said to you? You're the only one talking about ball.
I'm
Right.
saying his geometry breaks down on balls, and he won't admit it.
Because that's not what we
What
see in
does
real
that
life.
have to do? What does that have to do with him saying verticals are perpendicular to horizontal?
Because
You're saying, well, that
he
wouldn't work
knows.
on a ball. Do we live on a ball?
You asked me a question. Do you want me to answer?
Well, I just asked you this question.
Yes, I believe we live on a ball, and I think Bev is
Okay,
stating
how do
it.
you know that?
Hang on, I'm answering the first question now.
Yeah, but how do you know? How do
Don't
you know
worry
that?
about me,
We
Don.
already
I'll
got.
be
We
all right.
already
I'll
got
speak
that.
for
Elijah,
myself. Thanks.
Elijah,
I'll be
he just said
fine.
he believes. Okay, why are you? I mean,
Okay, and now I said, what's the justification for that?
okay, there you go. You said, how
I'm
do you
going to totally
know?
ignore your first question then, if you want.
What's the justification for you believing it's a ball? That's the question.
Nighttime. Obstruction at the horizon. Two celestial
Nighttime, did
points.
you just say?
Let him
That's
finish.
what I'm
The moon
saying. What
appearing
is
as a ball.
what are you just gonna affirm that it's a globe, which is your argument because nighttime? Is that the argument? Again, that's a
Nighttime's
fallacy.
one of my reasons for
That's a
thinking
fallacy.
it's a ball.
I'm
No, it's
just
not a
listen.
fallacy.
Every time
That's
I
not a
say
fallacy.
your word,
Axiom
every
one,
time I
mate.
say your well, if I listen by the definition and the form of his words, as true as anyone can hear what I'm saying, yes, he fucking did just commit that fallacy.
Wait, what was the fallacy again?
Affirming the consequent.
You asked him why he believes the ball, and he gave you like reasons why. I mean, this.
Okay, so
how is
I
there a
believe in
fallacy?
ball because of nighttime. It's nighttime, therefore Earth is ball.
You
What the
asked
fuck
me
is hard
why.
about this, Armor?
Tis globe. That's
Well,
good enough
I'm
proof
sure
for
there's-
me.
I'm
That's
sure there's-
dogmatic globe proof right there. I mean, how
I'm
can
sure
you
there's
not
more.
accept that?
I'm sure there's more context to what he was about to say. Like,
No,
okay,
no. The words in form, by definition, is affirming the consequent. I don't understand what's so
He's
hard.
got me there. Tis globe, right?
Elijah, do you want to know more about why I think it's a globe, or are you going to pretend that it's all
Well,
just
you
a
said
fallacy?
horizons obstructing everything. Well, geometrically speaking, since we wanted to talk about geometry and how you're just using math, but it's not in reality. Well, okay, well, show me the geometric horizon. Speaking about math.
Yeah, all
Yeah, you're so
horizontals are
confused.
parallel
Come
to the
on.
plane of the
You're so
horizon,
confused.
right, Dawn? Isn't that
What?
where we started off?
He says no.
He says
He said
no.
no.
Wow.
I'm
So-
not really making claims. I'm just telling you that your
Sounds
math
like that's
only,
you're making a claim that
your math
that
only fits the
definition for
hypothetical flat
horizontals
Earth.
is not true.
My claim
On a
is
theoretical globe, you can't have that. He already said that.
Right. Okay. In reality, can we have it in reality?
What?
The all horizontals being parallel to the plane of the horizon.
Not on the surface of Earth, no.
Right. So the definitions of horizontal being parallel to the plane of the horizon, they're assumed wrong, are they?
No, horizontals still can be horizontal, parallel to the horizon. That can still work.
But if
How far can they work? At what point are they not horizontal
If
anymore?
all horizontals are parallel to the plane of the horizon, then all horizontals are parallel to each other. It's a mathematical
No,
principle.
that's
Yeah.
absolute nonsense. If
No,
Earth's
it
flat. Sorry.
follows. It's
if Earth's flat, yeah, but we
it's
don't
not.
think it
No,
is.
no, we're not talking about the Earth. We're just talking about horizontals being parallel to the plane of the horizon.
If you say in reality at the beginning of that question, my answer is no.
Okay.
Sorry.
Right. So, But you disagree with all definitions of horizontals.
What's the definition of fast again? I just want to hear what's the definition of fast of horizontal? Say that again. What is it?
I don't know, you said it too fast.
What is the definition of horizontal again?
You have a look. Don't bother asking me. Go and look for yourself.
Well, you said it earlier.
Off you go. Off you pop. Go and have a look. Everybody do it for themselves. Don't trust me. You can't trust me. I'm just Bev. Look for yourself.
But if I look up horizontal, though, I'm going to obviously get the math definition, right? And that's only going to give you, like, I want the actual definition for horizontal, like on, like, Earth or whatever. When you're doing measurements.
The plane of the horizon.
That's only one definition out of about 5.
That's the one that we're using for this argument.
So
find us a different one.
Okay, so hold on. Parallel to the plane of the horizon. Isn't the horizon, obviously a different location depending on where you are? So if I'm, in America, the horizon, or in New Jersey, more specific, right? And I'm looking out wherever, right? My horizon is going to be a different location than yours, obviously.
Absolutely.
You know what I'm saying? So
all horizontals will be parallel to it, though, right?
No. Because if we're on a ball now, right? That definition still holds up, where the parallel is still perpendicular, or might be parallel to the horizon, whatever.
Yeah. In reality, though, right? All horizontals will be parallel to the plane of the horizon, won't they?
Sorry, hold on. I was reading text. Say it again.
In reality, like the reality that we all live in now, if everybody wanted to go out and check the definitions that they've already checked, then they could go out and affirm this, couldn't they, for themselves? That all of the horizontals where they are indeed parallel to the plane of the horizon. They could even walk around for a bit as well.
How would they confirm that?
How would they confirm it? By checking.
That still checks out with the ball, though. You can still be able to...
slope, right? You know the definition of horizontal. No slope to any position.
He's changed it, see? He's using a second definition now in the same argument.
No, that's what horizontal is. Everybody knows that, right?
Parallel to the horizon and this
with
other
zero
stuff
slope, yes. As horizontals are. Zero slope. Everybody knows this.
I don't know. Then I don't know. I had it last.
He's hot micing.
Eli, I think you're hot micing.
Yeah.
First, of course, horizontal follows the shape of the Earth. Some might say.
But what? Horizontal's a straight line, though, Dawn, right?
I'm at this point. I'm willing to totally rape the word horizontal and change it into the same meaning of level.
Go on.
Just to piss you off.
Yeah, go on. So horizontal's what?
It's curved around Earth sometimes.
Right.
So now you just want to change the words.
Give us bendizontal, Dawn. Come on.
You've already got it. I'm just doubling down.
Like how you said,
bendizontal, Dawn.
You misunderstood horizontal that badly that you thought it couldn't stretch around the surface of a ball.
It's a straight line, Dawn. Everybody knows that. Or a plane.
Imaginary thing that you got from a tool. Everyone knows that.
Dawn, I just like how you said sometimes.
Yeah, because locally it's totally flat, level. But over long distance, all the horizontals meet, creating a big circle.
Something like that, imagine. Maybe.
Because Bev's ready to use the word level and horizontal whenever he wants, maybe we should. And if everything means curved around a globe, he'll have nothing left to speak on.
Just check. I don't know how many times I've used that. I've been talking about vertical and horizontal being perpendicular.
Yeah, it's always imaginary lines with you, isn't it?
Yeah. Well, look, Bev, I obviously love it. And I hope you're proud how I can argue alongside you, bro.
Oh my God. You don't even know the difference between level and elevation change.
Right, you obviously do though, Dawn. You're the one speaking for this. You've just bendizontaled, Dawn. Anybody else want to go against Dawn? You might have found yourself a new power here, Dawn. I think a lot of people have already sussed onto this. They can just come into an arena and state some really stupid shit and then get the support of a band of brothers, maybe.
Looking at your reflection, how does that feel?
Arma said that.
Wait, what happened?
Parallel doesn't have to exactly be parallel.
No, I'm saying in terms of like, okay, if I was like, oh, I'm gonna make this shelf. Whoa, can I? I was talking. Come on, guys. Okay. So if I said, okay, I'm gonna make a shelf, horizontal, oh my bad, parallel to the floor of my house, right? Like it's technically not parallel because there's not infinite precision on that. If I was to extend that indefinitely along with the floor of my house, whatever, they would probably meet
That makes
at a
no
really great
sense.
distance. So that's
It
what I'm
makes
saying.
no
Like,
sense.
what?
That's not even true. I don't even know why you're saying that.
You really think you can get perfect parallel, like a parallel
He
shelf
has to
from
say
the
that.
floor? No, I'm saying no. Seriously, do you really think you can get
Yeah,
100% parallel with the?
yeah. Parallel is parallel. Period,
Are you?
bro. That's
No one
Modern
has
day
it. Are you
sophistry.
serious right now?
Please don't
No,
try and
hold
do
on.
this to
Hold on.
mathematics. Like, come
Hold on.
on, who's
Hold
gonna
on. Hold on.
like?
oh my
Don't. You're
god.
doing this to
I'm
yourself. You should stop
I'm
Oh my
Arma,
it.
yeah,
god.
within a
Oh my god.
realistic.
Literally, we have Rakia who talks about creating uh a horizontal using level water when he fills up. Well, he said something about filling something with cement and then putting water on top to see where the imperfections are.
That's still not perfect.
In that situation, no, it fucking is, fam, because water
Oh
is
my god, you're
perfectly
serious right now. You're actually fucking serious.
horizontal.
You think we can
Yeah,
get?
because water is perfectly level. That's why.
That doesn't matter if it's perfect
Arma,
level or not. You're
Because
still using
water
human
at rest
hands.
is
Hold on.
perfectly level.
You're still
That's why.
you're still using your human hands to set the shit up or whatever the fuck it
But
is. I
you're
mean,
sitting here arguing. You're not arguing against horizontal and perpendiculars. What you're saying is, we wouldn't be able to get precision. But that doesn't even have
No, he's
anything to
saying
do
on
with.
his globe, right? On the monad that he's worshipping, this doesn't occur. That's what he's
That's so
saying.
funny.
He's saying it's
no,
slightly different than
That's
actual reality.
you guys
that
are whack
sounds
if you
very
think you can get
desperate,
perfect.
bro. That sounds very desperate. If you're not like perfectly leveled or perpendicular to the atom, bro, you're saying that over
Yeah,
a
you
distance
are.
it's gonna
That's
compound and throw you off. Is that really your argument?
yeah, because that's what Elijah was saying earlier.
Yeah, that's
Elijah was
exactly
literally
what he said.
saying that
You're
we.
right.
Oh no, hold on,
That's
Elijah.
desperate, bro.
Modern
Because
day
no, it's
sophism.
not desperate. Hold on, I'll tell you why it's not desperate. Because Elijah literally said, "Oh, something about me earlier saying that parallel isn't exactly parallel or some shit." That's kind of the
Yeah,
argument.
but you're
I'm saying,
saying
yeah,
if you zoom out like that comedian says, if you zoom out, then you'll know that parallels are parallel because we live on a sphere. That's basically what you're saying without saying it. But
no,
that's crazy,
let's just
man.
address what you
That's
said. What
crazy.
you said earlier. You said that I said, all right, that parallel,
You did.
doesn't have to be perfect or it doesn't have to be truly parallel, whatever, right? And what I said, right, to
Yeah, you
that
did.
is that, yeah, and what I said to that is that sure, because if I was to set up a shelf in my house, right, and I want that to be parallel with the ground, right, technically it's not going to be perfectly 100% parallel. For human standards, sure, but I mean, in terms of, perfect parallel, nothing is
In
perfectly
terms of
parallel.
if you
That was my
increase the
argument. So
distance,
therefore,
that's what you said. You basically said if you just kept going.
yeah, that's
Yeah,
the whole point. Yeah,
we all
because
heard what you said.
that's how parallel
We all
works, right?
heard. Look,
Yeah,
look, I
that's how
heard you. That's
parallel
why you're
works.
like, yeah, yeah, you heard
Yeah,
me,
that's why
bro. That's
parallel.
the
Yeah,
point.
that's why
We
parallel.
addressed. Listen. We addressed that, and you're saying, yeah, you heard me.
Yeah,
Yeah, we heard what you said. We addressed what you said.
yeah, that's how
That's just,
parallel
it's
works, though.
insane for you to sit here and I know, but now you're getting really excited about
Yep,
uh
you're being
parallel
silly.
things not being parallel, and it
Yeah,
makes no sense.
because that's how parallel works, right? If I was extended out infinitely, right, they should never touch. That's why I'm saying it's so stupid to be like, oh, parallel, has to be perfect, whatever, right? Like, if you want to truly be that guy, then okay, then nothing is parallel, right? There's no such thing as a circle, no such thing as spheres, whatever, because
No,
we can never get that kind of
no,
precision, all right? No,
you're
we
saying
can
that
still define it
nothing is
as
parallel.
parallel or effectively
No such
parallel.
thing as
You
spheres.
hold on,
I
hold on,
play
hold on.
basketball all the time. I know what a
You
sphere is, but
you do understand
what's
that
that got to do with?
there are tools, right? With like you machine pistons
Okay.
that are like accurate to the 40th micron, like
Yeah.
extreme precision, bro. You're saying that that's not precise enough for you?
That's not infinite precision, though. I'm saying in terms of if we want true parallel, you have to have infinite precision, all right? That was the whole argument. If you want to get really technical, but that's stupid,
It's
though.
not technical. It's sophistry.
My whole point is that
No,
you
but
could.
what he's saying is,
Hold on, can I?
if we really think about it, and you get enough distance in between it in our reality, which is a sphere like, of course it wouldn't be parallel. That is basically what you're saying. Dude, you're religious as fuck.
I don't know if I was really okay. Look, point is, all right. All I'm saying is
This is
that
a very
if
old
something is close enough to
argument.
parallel, I was literally just trying to like steel man, I guess, Dawn, wherever. I was just saying that technically speaking, nothing is truly parallel, right? So if we have something close enough to parallel, we could just call it that. Like, it's practically parallel. I'm like,
yeah,
sure,
you
why
can
not?
always imagine a monad, right? If not parallel, right? At least you've got a chance. If you've got parallel, that's perpendicular. Then I don't know. It's troubling for you, isn't it?
I'll give you another one. Telephone poles half a mile apart are parallel and not parallel at exactly the same time.
Yeah, that's stylism, that Dawn.
Well, no. They're effectively parallel. They're effectively parallel, right? But if you want to get really technical, because they're on. Oh, hold on. Yes, they are effectively parallel, right? But the thing is, because
parallel and not parallel.
Let me finish. All right, I said they are effectively parallel. Let me finish, man. So they are effectively parallel, right? But if you want to get technical, because they're on the surface of a sphere, all right. They're never going to truly be parallel, all right? They're not, you know what I'm saying? Like they're for all intents and purposes, they're parallel, but really, if you really get precise, they're not, all right?
So you are begging the question then, and using a definition of level that's a contradiction in its own self.
I don't
And there's only one place that you can find. There's only one place you can find that definition is Merriam-Webster under adjective 1A,
all over Google.
and it says having no surface or higher with respect to the curvature of the Earth or some shit like that. That's a contradiction immediately, fam.
I'm just still manning Dawn. That's it.
Depends how much the curvature of liquid water is, doesn't it? I mean, what is the curvature of liquid water? It states a little bit earlier that it's a horizontal condition. Surprising that, isn't it? In the same dictionary. So can a dictionary contradict itself? Is it possible?
No, because
modern
it has two
day?
different contexts. It has two different contexts.
There's no different context.
Yes, there is. The definition of level is also found in surveying dictionaries or surveying manuals.
Only on McToons. The worshipping the shrine of McToonery. That's the only place, isn't it?
Why do you bring up McToon?
No.
Because in surveying, level and plumb are perpendicular, and representations, vertical and horizontal, are also perpendicular.
And in surveying, what shape is mean sea level?
It's not a shape, it's a vertical datum. It's a point on a vertical datum. It's an elevation.
Okay. And when you take all those datums and you plot them out, what shape does it make?
Well, I don't know. They're just heights above mean
sure
sea level. Well, what's a geoid? Can you define geoid?
Yeah, roughly spherical.
Well, that's what you get when you map out mean sea level changes. Because the map of the UK that measures mean sea level changes is... I've got it on the wall.
The one made by the company that told you Earth is a sphere? That company?
I don't know. Did they? They didn't. Some dude on Twitter, you mean? I don't know what you're doing.
Works at that.
We're talking about vertical and horizontal being perpendicular.
Yeah, that answers Twitter questions for that company. Is that the one you're talking about?
Don't make such a big deal out of it. It's like it's some sort of a setup that you're relying on something that somebody said on Twitter. I mean, I wouldn't rely on that at all.
That was what you said.
I'm just asking a clarifying question. Is that who you're talking about?
The map? I don't know who makes the map.
No, the company that told you the Earth has curvature. Is that the one you're claiming?
There's loads of curvature. You see it all over the place. We were talking about it earlier.
Now he's on about the curvature. He admits the curvature, but it's not the globe.
Yeah, the mountains. Like, can you not see the curvature? It goes up and it goes down. It's all over the place. Everyone can see it.
And the oceans are curved as well, right?
The waves, tides, oceans, definitely.
You think, is that what they told you?
Is what they... Who's they? What are you talking about? We're talking about vertical and horizontal being perpendicular. Are you saying somebody says that isn't a relationship?
Ordnance Survey is they.
Okay.
They are the ones that...
I haven't really talked to the Ordnance Survey, actually.
Well, who answered you on Twitter?
I don't know. Some random person in an office. I don't know. The Twitter representing... I don't know. They might have outsourced it. Probably have, actually. It's not a government agency, you know. It's not a government agency, you know.
No, I didn't say it was.
Okay, right. So it's just some random representative. Twitter.
No, it's not a Twitter representative. Who do they represent?
On Twitter. Who do they represent on Twitter?
Yes, which company on Twitter do they represent? Was it Ordnance Survey?
I think so. It might have been, yeah.
It might have been. It might have been.
Okay.
You don't remember? Or you're lying? Which one?
I don't know. Why are you bothered about what somebody said to me on Twitter?
I'm not the one who seems bothered, Bev.
Are you the one that said it? Are you? Is that you? Don't tell me it's not. It's not you, is it? No, it wasn't you on Twitter.
No.
This conversation is insane.
Now it's weird, isn't it?
Why don't you try get to things that you actually believe, Bev? Try and talk about
vertical and horizontal are perpendicular.
No, I mean real things that you believe.
Well, maybe
not math proofs that you learned because you thought it was fun. I mean real things you believe. Why don't you talk about that?
Real things?
Yeah.
I tend not to have as many beliefs. I try to have knowings.
Don, you know he doesn't believe in real things.
I know. That's why I'm teasing on this point. Because
I know about real things.
You want to talk about
they're real. I know about them. Do you want to ask me what I know?
Yeah. What do you know?
I know that level is horizontal.
Do you know anything about real things?
Yes, I know that level is horizontal.
I'm afraid that's two concepts.
To you?
But no, to anyone.
It's not a concept. It's what you get.
If he says yes, I know an inch.
It's what you get when you
25 millimeters.
Like, I'm sorry, you definitely interrupted me, and I definitely waited for you to finish.
You're about to white
that's
knight
what
nonsense.
But that's what's weird about this. Just because you're saying I'm white knighting doesn't change the fact that it's weird that you would interrupt what I'm saying. I mean, you didn't say Arma stop white knighting for me. You didn't say, hey, this other guy stop whiting right.
What is real about
just say your point.
What's real about vertical?
There's nothing weird about that. I said what's weird.
What's real about
is that what do you mean what's real about it?
What is real about the concept of vertical?
Well, it's real to you, and it's real to you until you're saying, well, it's really just a concept because we live on a sphere. Like it's real until
you're not getting it.
You believe that. No, I am getting it.
Would you agree with me? It's a concept, the idea of vertical.
No, that's dumb.
What do you think?
You just drop a plumb bob. You just drop a plumb bob, and boom, you have a vertical.
So you mean
what's not real about that?
Vertical.
Yeah, the only way you have a vertical is if you have a horizontal. You can't have a vertical without one.
So you've changed the concept of vertical to an actual weight and an actual.
They're perpendicular, Dawn.
Elijah, you said you just drop a plumb bob. What do you need a horizontal for?
Yeah. Exactly.
Where did you mention horizontal in there?
Well, there's no such thing as horizontal. There's no such thing as horizontal without vertical, and vice versa. What are you talking about?
Well, there's a relationship between the two, but you don't.
They're perpendicular, dudes. What's up with that?
You happen to have both, but you don't need one to have the other.
They come together. You can't separate
them.
At
a point. At a point.
No.
They come together at a point.
No, they're planes.
Look, boss.
Planes that touch a point.
Don't worry, it happens in reality. Don't worry. There's no need to fear it.
Are you fighting?
I'm not fighting. I'm just saying to you guys, there's no need to go against a perpendicularity of vertical and horizontal.
No,
or the
right.
planar nature of vertical and horizontal.
But they have very little, they matter very little when we're talking about the Earth, right?
Yeah. Well, to me, I'm not talking about the Earth, but it seems that they matter a lot to you about me talking about them, not relating them to the Earth.
Why are you talking about concepts instead of the Earth?
Because I didn't want people getting fooled by somebody who was giving them a proof that isn't actually a proof, right? They've been fooled by measurements taken.
Instead, you're asserting math that doesn't relate.
No. Your concepts have little to do with those measurements taken there, Bev.
The vertical plane that the measurements are supposed to be taken in over a distance that isn't optically possible.
Do you mean like LIGO?
No, we're talking about Jesse, aren't we, in the vertical plane? Or are you talking about the horizontal plane of LIGO?
Why are you talking? Is this picture from how long ago?
Are we now talking? Let's do LIGO. LIGO's a good explanation. LIGO's on a horizontal plane, right?
Well, the tubes are, yes.
Okay, both arms.
Yep.
On the same horizontal plane.
Yes.
Okay. Do you know? Can you explain why there's a 4-foot slope down one arm and a 4-foot slope down the other arm, and making an 8-foot slope across the perpendicular, the hypotenuse?
No, it's not a 4-foot slope down. It's a 4-foot curve up.
What? It's a horizontal plane, right? The plane doesn't curve up. What are you talking about?
No, it curves up from level.
It's a horizontal plane,
or
mate.
more accurately, level curves down from it. That would be more accurate.
Wow.
Apologies, I woke up recently.
That's insane.
Are you sure?
Why? Yes, I'm sure that I made a mistake first, and that is the more correct thing to say.
Okay, so
the level curves down.
Okay.
No.
See that horizontal plane you've got there, right? All the perpendiculars to that horizontal plane. Will they be vertical?
No.
Oh. So you've got a horizontal plane that they built LIGO on that has
with reference to what? Wait, with reference to what?
With reference
to the plane? Yes.
Right, so plumb bobs is how you would establish a vertical, right? In reality. In it.
On Earth.
You would set your tools up, right?
They would not be vertical.
They would not be.
Right, but about Earth now, Bev. No, they will not be vertical.
So there's a horizontal plane that LIGO
Bev,
sits in.
Are you recording this?
Absolutely. Yeah, there's a horizontal plane that all of the verticals won't be parallel to it.
More imaginary lines, Bev, from you.
Okay. So if you have a vertical plane for each of the arms that it's lying in, if we were to do an elevation profile, what would that look like?
If we had an imaginary wall sticking up and then two imaginary
No, this is a
real.
real thing. It's LIGO. It's one of the most technical things that's ever been built. Some of the people that I know have talked about it being the straightest thing in the universe.
You're suggesting that it's lying on a flat Earth and must.
I'm just trying to get a vertical plane along each of the arms and what an elevation profile of these arms would look like, seeing as they're on a horizontal plane.
It would go around a globe a bit, wouldn't it?
On a horizontal plane.
If you're going to call it that, yes, the horizontal plane.
No, I didn't call it that. Chunky.
Who did?
Chunky. It's a horizontal plane.
You
LIGO.
started it.
What did you call me, Beth?
Chunky.
What's your name? Don't make me use your name.
Bev, you've just used it.
Bevidian.
There you go. Dawn's gone even better. So,
yeah. Try not to straw man Chucky with horizontal planes if you're discussing something that's attached to the Earth.
Yeah, with vertical planes we were talking about along the arms. The perpendicular to the horizontal plane that's been made.
It's not a horizontal plane if it's attached to Earth, is it?
He said that's what the arms are in. The arms are in a horizontal plane.
You started that bullshit.
Yeah, are you saying he was wrong to agree? Or the arms of LIGO are not in a horizontal plane?
And the reason he agreed
we've not got any better.
You stated an invisible horizontal plane and then quickly word gamed
we said the arms.
as if LIGO was stuck to one.
Yeah, we said the arms of LIGO lie within a horizontal plane, don't they?
You just
and he
said
said yes, they do.
Yeah, so you tricked him.
Oh, that was a trick.
Of course.
Oh, right. Well, him agreeing was the trick, or me asking was the trick? Which one?
Why do you do it?
Did I trick him into saying the wrong thing? Or was it his agreement with me that
trying to help
LIGO
you.
must lie in a horizontal plane somewhere.
He's trying to help you, but you suggest things have to be horizontal at the beginning of each sentence, and people sometimes miss it.
Okay. So, is there anybody else who willing to state whether LIGO arms either do or do not, or maybe even both, like Dawn's suggesting? They could be both. I mean, Chunky could be both correct and wrong at the same time, couldn't he, Dawn?
What's the distance of it?
LIGO, do you not know about LIGO? About 2.5
No.
miles each arm, perpendicular to each other.
What's an arm? How long is LIGO from one end to the other?
2.5 miles along each arm. Each
Yeah,
arm
what is an
is
arm?
perpendicular to each other. They fire lasers down these things and bounce them back. They're
So they fire-
straight arms,
Do you mean
perpendicular
the
to
arms
each
are,
other.
are the arms the stands for this thing?
The concrete pads.
No, that
Come on.
the arms. He's correct, Don, in that the
So the arms are perpendicular to the actual LIGO thing. But he asked for an elevation profile, didn't he? That was not going to be parallel.
You're talking all over him. Look what you're doing to him. Go on.
He's robot.
Straight.
You're robot, sorry.
But they deviate from level because they're perpendicular. No, you're right. You're right. That's what I mean. That the level of Earth curves down from the arm.
Yeah. So his trick is suggesting that the arms are perpendicular to the object, and then he wants people to believe that means they're all going to be the same.
Can we have
on the same
an established curve down? It is horizontal, right? The plane that the arms lie in, they're horizontal, right?
You don't know what you're talking about because you keep speaking wrong every time.
He's telling. Don't stop talking over him.
At the point.
Roboting. I can't hear him.
So it is a horizontal plane. They both of the arms lie in a plane that at least is horizontal at one point.
At one point. Sure.
See, there you go. Look.
Anything can be at one point.
Yeah.
Anywhere.
Horizontal.
But if you've only got 1 point, it's not a plane, is it?
Right. And then are you saying that the elevation change occurs from that point of the horizontal plane? No, I'm not talking to you, Dawn. I know you know nothing about this. It's obviously
That's not just what I say. That's what the surveying company says.
Okay, so there's an elevation change of the horizontal plane.
Are you asking me because you don't know, or you think I don't know?
I'm just trying to ask you to confirm that you state that you think there's a elevation change of a horizontal plane.
It's not just me that thinks that. Who thinks that, Bev?
I haven't got a clue. I don't know what other people think. That's why I'm asking you. Can you confirm it?
Okay, did you look at the drawing?
I'm just going off what I know, right? I'm trying to make it clear for everybody to see that what happens in reality. No, I haven't got a clue who did the survey.
Yeah, what happens in reality, Parsons Engineering.
Mm-hmm. I know the as-built would have been done afterwards, right? Not the actual blueprint plans or anything. You've never seen those actual blueprint plans. Of course,
the as-builts are done after it's built.
Yes, by the company that own it.
They issued for construction drawings.
No, not from the construction.
You know all about this, don't you, Bev? You know about IFT.
Yeah, I know all about the as-builts.
Yeah, you know about IFT, IFC,
post
and as-built drawings.
Post construction,
right? Based on, and they're called red lines because they put red lines on things that are different than the IFC drawings, right?
I think he had like a call or something. I heard his phone going burp, burp.
Yeah, it was 1984 calling him.
Chucky, is, in your opinion or your knowledge, is LIGO curving around Earth, or have they built their own platform for it, 2.5 miles long, that's flat?
Yes, they built a well, not a platform really. It's just two foundations for tubes, and those are straight, and Earth curves
under it
beneath it. If you
we
will.
can tell Bevy is correct about the arms being a horizontal plane.
So it curves away from that.
Yes.
Right.
Yeah.
Okay.
But they're only horizontal at the point where they meet.
Yeah, where each one.
Okay.
Yeah.
So why is there? Oh, so that's why there's an elevation change across the thing. It's 4 foot, 4 foot, and 8 foot over the entire thing. That sounds a bit linear, doesn't it?
Yes. No, it's not 8 foot over the entire thing.
Yeah, it's 4 foot on each arm.
Yeah,
at least
and
for
the arms are roughly
one.
90 degrees.
Yeah, so that's so from A to C across the hypotenuse, there's an 8 foot change.
No, the two ends are at the same level.
No,
right?
they're on the horizontal plane.
Aren't they
and the
same
horizontal
length?
plane goes. No, have you not heard? Blue marble. It's this one goes. You start at one. It goes up. I think up. Is it up?
Actually,
8 foot to the apex, and then up another 4 foot. Sorry, 4 foot
but he just
to the
tried to
apex,
get
and
you-
then 4 foot back up again.
Okay, if you start at 0 and go to -4, and then the other arm goes from 0 to -4.
No,
how is
no,
that
no.
8 feet?
No, it's up
Yes,
4
yes.
to the apex, and then turn at the apex and go up another 4.
No.
So, yeah, Hanford.
You go from the apex. Down one arm, 4 feet, and if you go down the other arm, it's also about 4 feet down.
No. One goes. The arms go opposite. One goes up to the apex, and then from the apex, the other one goes up. Blue Marble did a thing
Then
about
that wouldn't
it
be
the other
parallel,
day.
or it wouldn't be horizontal. Yeah,
Well, I don't
and
know.
you misunderstood
I
it.
don't
Bev.
know. So it's not
Because
horizontal.
He probably
now,
didn't repeat himself enough.
So LIGO does not lie
Probably
within a horizontal plane.
He didn't repeat himself enough, so you didn't get it through your head. No, nobody said that.
Okay.
If it went up as you say, then it wouldn't.
Oh, well, I mean, that's what Blue... I don't say that. Blue Marble's the guy that says that.
Okay.
And Blue Marble and Betty, obviously. Have you been keeping up to date with those? Is it rational?
And I bet...
Not only that, Osho, Zanuck, Dogmatic, all these guys say the same thing.
It's
Are
4
you
foot, 4
pretending it's the
foot
first
up
time you
one.
heard this, Chucky?
Yeah, he doesn't... He doesn't seem to know that there's a 4
no,
foot up.
Has Betty been on Blue Marble using it?
He knows.
No.
He's heard it many, many times, right, Chucky? Don't play that you haven't heard this before.
Well, guess who supplied those as-built drawings?
Don't know. Was it you? Maybe Blue Marble Science. Yeah, I don't know.
Science name over and over again.
I was doing a Zanuck thing earlier.
It was me. It was me. Yes, in Discord. What's it doing a Zanuck thing?
So it was you that supplied the drawings. We missed most of that.
I supplied the link to the drawings. And then he did a great video on it. At which point, at no point did he say that it went up and then up.
Yeah, he did just in the last couple of conversations that he's had.
So then it wouldn't be a horizontal. It wouldn't be on the same plane, would it?
I don't know. Like, I haven't got a clue what happens in your stuff. So you supplied the things to him. Was that you that supplied the wrong information, or has Blue Marble interpreted it wrong?
No, you interpreted what he said incorrectly.
Oh, I think I've got it here. Look, there you go. Check that. That's what I did. 4 foot, 4 foot, 8 foot. But I got it the wrong way round. I didn't know which one was the one that was higher. So it turns out that I think C is the one. You just have to imagine the letters the other way round, or I put the slope the wrong way.
Which one is the intersection? A?
No, B is where the apex of the two perpendicular arms. So you've got AB and BC. And it's supposedly, no.
Okay,
no.
what's the apex then?
What the apex? Vertex? 4 foot. It's 4 foot. It starts the top, if you will, of your ball is at one of the arms, and then it goes up 4 foot to the apex, and then from the apex up the other arm, it goes up another 4 foot. So total from A to C, there's an 8 foot change of elevation.
Listen to me. We're going to set the elevation at the vertex of the two arms at 0. If you go down arm A, level goes down the elevation is up 4 feet. And if you go up the other arm, the elevation goes up 4 feet. But that's from the vertex. Do you know what those words mean?
Have you had a word with Blue? Do you want to have a word with Blue Marble? Is he around here? Has anyone got it on the hotline? Blue Marble.
I don't know. Do you know how to read his name to see if it's in the chat?
No, it's not in the chat.
Why do you keep invoking the man? Just get on with your
Because he's the one that said there's an 8 foot elevation change.
No.
Yes, he has. Beth. Definitely no. I'm telling you.
Yes, he has. I heard him say it. That's a fact. We made a video. There's no disputing that. Blue did say that. That is a fact.
8 foot elevation change from where to where?
From the start to the end. If you go along one arm, 4 foot to the apex. From the apex along the other arm, another 4 foot. So from A to C, 8 foot.
I think apex means the highest point. So what are you using?
No, apex of the angle. Where the arms are perpendicular.
That's at the vertex.
That's the apex of the angle, the perpendicular of the two arms.
What the fuck is an apex of an angle? I don't know. Maybe I'm slow today.
What maybe. Well, so we go from A to B, right? Where the two arms are perpendicular, we're going to call that B.
Okay,
like the
so
picture.
The vertex is B.
Can you see the picture in the chat?
No, I can't.
Oh. Can you actually have a look at it then? Because that might help.
Okay, but you're saying the vertex. You know what a vertex is, Bev?
Of the angle, yes. Where the two lines meet.
Okay, is that the apex you're talking about?
B, yes, where the two arms meet. Yes.
Okay, so at the vertex, what about it? Is that 0? We're calling that elevation 0.
No. You put an arm. Start at one end of one arm. Now you're going to go to that point, right? B. You're going to go from A to B. I don't know why this gets really difficult.
We're going down 4 feet of elevation.
What, with the concrete?
Yes.
Okay. And then there's
We're
another...
decreasing elevation from A to B.
Okay. And then you go from B to C, another 8, another 4
up
foot.
In elevation.
Another... No. 4 foot down. Yes. If you're going down, you're going down. If you're going up, you're going up. Right? You go up along the whole travel. According to Blue Marble Science. According to Blue Marble Science, you start at one end of one arm. You travel and you either go up or down 4 foot. You reach the apex. You then continue to go down the other arm and you go in the same direction, either up or down. You go up, or down, down.
Incorrect.
Well, have a word with Blue. Have a word. That's why I said.
He was fucking with you.
Well, he might be fucking with us, but it appears that there's a lot of people trying to draw drawings.
So did you correct him when you showed him the as-builts?
I haven't showed him the as-builts. I think he was working from the as-builts. To be honest.
Did you look at the as-builts?
No.
Why not?
because I'm just waiting to see what people say. I mean, Blue Marble's the Blue Marble scientists, geodetic surveying
if
crew.
Blue Marble
I'll just
said,
go with what they say.
If Blue Marble said you go down an elevation from the end of the arm to the vertex and then go down again, he is incorrect. But I don't think he said that. Unless he said it by mistake, at which point you could have corrected him if you had the estimate, which you can get for free online.
So it's either he did, you don't think he said it, but if he did say it, then it was a mistake. Wow.
Okay.
He's wrong.
He's wrong. Says.
Oh, there you go. There you
he's
go.
wrong.
There you go. Using your own.
The as-builts don't say that, so I don't give a shit telling you how it works in reality.
So it would be a horizontal plane though, and there would be an elevation change, and you're saying it would just be 4 foot from the horizontal plane, because the highest spot would be
if you're
the apex.
No, if you're talking about the horizontal plane from the point of the vertex, not the apex, the change would be 0.
What, on the horizontal plane?
Otherwise, it wouldn't be a plane. Right. If you're talking about the surface of Earth, yes, the ends of the two are at 4 level is 4 feet below at each arm.
4 feet below, measured vertically.
Yes.
Like a rise over run.
No, not like a rise over run.
Okay. So how do you measure that elevation change then?
Slope.
It's a slope.
Vertically.
Yeah, you measure it vertically at the other end. 4 foot.
It's a curve.
What, 4 foot? A 4 foot change from 0 over a distance is a slope.
A slope is straight. A slope is straight.
Yeah, as are these arms of LIGO.
Right. But the level Earth below it is not. It's curved.
Yeah, but are you saying that the horizontal plane has a slope then?
It's level.
Yeah, so the horizontal plane has a slope because that is straight. Isn't it?
Well, if you want to say it has a slope?
Oh, that's a pity.
Sure, but I wouldn't. Why would I?
I wouldn't say it has a slope. I think that's fucking ridiculous because horizontal planes don't slope.
A slope of 0.
Yeah.
There's 0, Bev. If you want to call that a slope, sure.
Well, no. I would say that's why we do rise over run. So if the LIGO's the horizontal plane and you do that as the run, right, with 0 slope, then the vertical would be an elevation change of the land, wouldn't it? Going down the level.
Yeah. So I don't know why you brought up rise over run here. You just say words.
So there is a slope of the level then.
There's a slope of the level. No.
Oh.
There's a curve to the level.
Oh, away from the no slope horizontal.
Yes. Horizontal at a point, and it curves down from that point. If you want to call it that.
Okay.
So there is a rise over run.
Why is this
horizontal
confusing?
Rise over run? Yeah, that's exactly that. I call that an elevation change.
Rise over run is a slope, not an elevation change.
But a 4 foot elevation change over.
Didn't you take surveying?
2.5 miles.
I only took one course.
Did you? That's rise over
run.
I
took one course in college, Bev. Did you not take more than I did?
It's rise over run, though, isn't it? The arm would be a horizontal, and the change would be a 4 foot change from the horizontal. The run would be the horizontal distance, and the rise would be the vertical distance. Rise over run gives you slope.
What is sloping?
Rise over run.
How many units?
Yes, on LIGO, what do you think is sloping?
How many units you move up or down from point to point? So if there's any change from point to point, That's what that's talking about.
It's the hypotenuse, right?
You're not coming in, Elijah, if that's you. Unless you're talking to Google.
Yeah,
You're contradicting yourself because you're saying there's a 4-foot change from the level. That would be a change in elevation from point to point, which is why he's saying so there's a rise over run. But you're saying no because you think that level is equidistant of here. So
There is a 4-foot total difference, but it's on a curve, not on a straight line. Almost straight because it's not very long, but it still is a curve. And if you're talking slope, you're not talking about a curve.
this is kind of insane.
Yeah, it is. Eh?
No, this is normal. This is normal for these guys.
Well, what's wrong about what I said, SC?
You got rise over run, and you don't have elevation change.
What
Like,
does the
you
rise over
don't see
run have
that.
to do with anything? Okay,
Yeah.
fine. If you want to say there's an elevation change, we've established that. Why do you bring in rise over run?
Well, that you're talking with Bev there, so continue.
I know. So, Bev, why do you bring up rise over run? You seem to think it's relevant, SC. Why?
Do you know what rise over run means?
Yes, it's how you figure out slope, which is a straight line.
Okay, so you established a plane, right? A plane? And now you're saying that there's a rise over run on a plane. Do you know what that means?
Yeah, if you're talking about a horizontal plane, the rise is 0. So a 0 slope, if you want to call that a slope, fine.
A zero slope. Oh my god. I haven't even finished my coffee yet, bro. A zero slope.
What is the slope of a horizontal line? So y equals mx plus b, right? M is the slope.
Did you forget the 4-foot drop somehow?
Yeah, so y equals 4. What's the slope of that line?
You got a 4-foot slope, dude. You got a 4-foot slope. What don't you not understand about that?
No, we have a 4-foot elevation change.
Oh, come on. Like, nobody's going with this. Chunky.
Wow.
Yeah.
What is an elevation change?
An elevation change is a change in elevation. What else do you want?
Right. From one point to another, right?
If it's an even elevation change, then it's a slope.
Of the concrete pads, isn't it?
No, it's not.
Oh, come on. Don't tell me that they're measuring the elevation of the land referenced to the concrete pads of LIGO. That sounds more like reality than you realise. That's the horizontal.
No, they measure the elevation of the concrete related to the land.
Okay, so there's a 4-foot slope of the concrete then. The concrete is straight, isn't it?
No, a slope would suggest the elevation change is linear, but it's not a linear elevation.
It's a horizontal, it's a straight line. The concrete pads are straight.
Yes.
And there's a 4-foot elevation change.
But the Earth is not straight, Bev. The Earth is curved.
Does the horizontal change at 4 foot over that distance?
The horizontal doesn't change at all.
Doesn't change elevation at all?
Yes.
So the horizontal is the 0 elevation change now. Not so sure you should be talking about this. Yeah, always.
He nearly said what I said earlier.
I know, he says some stupid shit. That's why I'm sure they've got somebody on a button to stop him from talking. Just about the moment he's about to say some really stupid shit.
When you manage to trip people up, Bev, it's not because
he can't make his mind up. Is it a slope or isn't it a slope? It is straight and it does change at 4 foot. But is it a slope or isn't it a slope? You make your mind up. It's not my problem.
Are you okay with it being a straight and a slope?
Well, yes, obviously. Both of them apply.
That's
Right,
what we all
okay.
think. We just disagree what Earth's doing underneath it.
So, which is the slope? The land or the horizontal?
The LIGO device that was set on a horizontal is on a straight slope. We think Earth
do you know
is curving underneath it.
So it's not straight. Bev, in the line equation, y equals mx plus b, what is the slope in that?
We're talking about LIGO's arms sloping 4 foot.
Yeah, I know, Bev. No, we're talking about 9th grade math.
We're not talking about mathematical functions.
Yes,
sophistry.
I am, because I
I
asked
know
a question
you are,
about it.
but we're talking about LIGO arms. Now they are definitely straight, and you say they are horizontal, but you've got a 4 foot slope. So what's changing?
If you don't know these basics, Bev, you can't discuss LIGO. It's way too advanced.
Is the horizontal changing 4 foot? Or is the land changing 4 foot?
It just trips people up with the word.
Respected to the horizontal plane, yes.
So the 4 foot change is a drop of the land from the horizontal plane.
If you want to call it that, yes.
That's an elevation change.
That is correct.
Okay. So the land changes elevation in reference to the horizontal. Like we've been saying, that's how you measure elevation changes of the land.
Are we talking about the elevation change of the land or of the LIGO?
That's what I've just been asking you. You've just decided the land changes in elevation from LIGO.
No.
Yes.
The land does not change in elevation. The land is at 0.
So then the horizontal changes in elevation.
From one end of the arm of LIGO to the other, it changes elevation.
So that's a slope.
No, it's only
come on.
Beverly. In the line equation, y equals mx plus b. What is m?
This is fucking ridiculous. My dad's just called up. He wants to go out for a pint. It's a lovely day.
Definitely.
I think you guys will obviously be able to go over this with Blue Marble Science. I hope he comes back and helps you out with which part is sloping and where it's sloping from what. Okay?
You'll be thinking about when you drink your beer. You'll be thinking about Blue Marble Science.
Yeah,
Bev is a mechanical engineer, but I don't think he ever took landforms. So on this one, he's going to have to defer to me.
Right, okay. Well, I'll just say, I think everybody should watch out for sophists in the open, and also learn a bit of logic, bit of geometry.
It's good,
and
though, because you're going to have a beer. So.
Always keep on the level. Keep it honest. Keep it going.
I agree with Bev's first 2 points. On the level doesn't mean anything.
You better think again, my friend, because the door is closed and we're in town.